Welcome back to our channel. Today we are diving headfirst into the world of networking with a networking crash course. Whether you are a tech enthusiast, a student, or a professional looking to enhance your skills, this video is the perfect starting point to unravel the mysteries of networking. In this crash course, we will break down complex networking concepts into simple, easy to understand terms, from the basics of how data travels through the internet to essential networking protocols and security measures. We have got it all covered. Are you ready to embark on this networking journey with us? Buckle up because by the end of this crash course, you will be well on your way to becoming a networking pro. And before we begin, if you are someone who is interested in building a career in cybersecurity or a networking professional by graduating from the best universities, or a professional who elicits to switch careers with networking by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in cybersecurity with modules from MIT Schwarzman College of Engineering. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered. And if you want to kickstart your career as a networking professional in 6 months, then try giving a shot to Simplilearn's Caltech Cybersecurity Bootcamp. The bootcamp link is also mentioned in the description box below, and you can find all the details of the bootcamp by clicking on that link. Now let's take a minute to hear from our learners who have experienced massive success in their careers by opting out these bootcamp and postgraduate program courses.
You're never too old to learn anything new, whether it's an art, a new language, a new sport, or learning new skills to advance your career. Hi, I'm Philip. I'm 61 years old, and last year I upskilled with Simplilearn's postgraduate program in cybersecurity after working 30 years in the IT sector in various different profiles. I'm happy to tell you that I was able to clear and pass my CISSP and CCSP certification exams on the first attempt after taking the course. Funny story I want to share with you. I started off aspiring to be a DJ, where I became interested in electronic stereo systems and how they connected and how they operate and what made them function. And 4 years ago, I began a journey to understand and learn more about the cloud. On the way, I developed a natural understanding for the security needs and began to focus my studies to understand more about the cybersecurity aspect of the cloud landscape. I worked with many companies before as a security analyst and an architect on a contract basis, but I needed some stability, which I got with the job I just started with Infosys as a cybersecurity consultant. Happened after I took the course. I've been an adjunct faculty member at Prince George's Community College and been in many different learning and training experiences, but the experience as a student at Simplilearn is something I will always cherish. The course, I must say, was packed with practical examples. It was led by highly skilled, certified instructors. I believe in living a fulfilling life. At 61, I am still training students in martial arts. I've been practicing martial arts for the past 40 years, and my efforts were acknowledged by the Eastern United States International Martial Arts Association, where I was inducted into the Hall of Fame for a lifetime achievement of dedication service to the martial arts. I've been many things in my life, but first and foremost, I've been a learner. Be a learner first.
An introduction to network security. Network security is a set of technologies that protects the usability and integrity of a company's infrastructure by preventing the entry or proliferation within a network. Its architecture comprises of tools that protect the network itself and the applications that run over it. Effective network security strategies employ multiple lines of defense that are scalable and automated. Each defensive layer here enforces a set of security policies which are determined by the administrator beforehand. This aims at securing the confidentiality and accessibility of the data and the network. Every company or organization that handles a large amount of data has a degree of solutions against many cyber threats. The most basic example of network security is password protection. It has the network the user chooses. So recently, network security has become the central topic of cybersecurity, with many organizations involving applications from people with skills in this area. It is crucial for both personal and professional networks. Most houses with high-speed internet have one or more wireless routers, which can be vulnerable to attacks if they are not adequately secured. Data loss, theft, and sabotage risk may be decreased with the usage of a strong network security system. Your workstations are protected from hazardous spyware thanks to network security. Additionally, it guarantees the security of the data which is being shared over a network. By dividing information into various sections, encrypting these portions, and transferring them over separate pathways, network security infrastructure offers multiple levels of protection to thwart man in the middle attacks, preventing situations like eavesdropping, among other harmful attacks. It is becoming increasingly difficult in today's hyper-connected environment as more corporate applications migrate to both public and private clouds. Additionally, modern applications are also frequently virtualized and dispersed across several locations, some outside the physical control of the IT team. Network traffic and infrastructure must be protected in these cases since assaults on businesses are increasing every single day. We now understood the basics of network security, but we need to understand how network security works in the next section in slightly more detail. Network security revolves around two processes: authentication and authorization. The first process, which is authentication, is similar to access cards, which ensure that only those who have the right to enter a building. In other words, authentication checks and verifies that it is indeed the user belonging to the network who is trying to access or enter it, thereby preventing unauthorized intrusions. Next comes authorization. This process decides the level of access provided to the recently authenticated user. For example, network admin needs access to the entire network, whereas those working within it probably need access to only certain areas within the network. Based on the network user's role, the process of determining the level of access or permission level is known as authorization. Today's network architecture is complex and faces a threat environment that is always changing and attackers that are always trying to find and exploit vulnerabilities. These vulnerabilities can exist in many areas, including devices, data, applications, users, and locations. For this reason, many network security management tools and applications are in use today that address individual threats. When just a few minutes of downtime can cause widespread disruption and massive damage to an organization's bottom line and reputation, it is essential that these protection measures are in place beforehand. Now that we know a little about network security and its working, let's cover the different types of network security. The fundamental tenet of network security is the layering of protection for massive networks and stored data that ensure the acceptance of rules and regulations. As a whole, there are three types. The first of which is physical security, the next being technical, and the third being administrative. Let's look into physical security first. This is the most basic level that includes protecting data and network through unauthorized personnel from acquiring control over the confidentiality of the network. These include external peripherals and routers that might be used for cable connections. The same can be achieved by using devices like biometric systems. Physical security is critical, especially for small businesses that do not have many resources to devote to security personnel and the tools as opposed to large firms. When it comes to technical network security, it focuses mostly on safeguarding data either kept in the network or engaged in network transitions. This kind fulfills two functions. One is defense against unauthorized users, the other is a defense against malevolent actions. The last category is administrative. This level of network security protects user behavior, like how the permission has been granted and how the authorization process takes place. This also ensures the level of sophistication the network might need to protect it through all the attacks. This level also suggests necessary amendments that have to be done to the infrastructure. I think that's all the basics that we need to cover on network security, in which our next topic we're going to go through two mediums of network security, which are the transport layer and the application layer. The transport layer is a way to secure information as it is carried over the internet, with users browsing websites, emails, instant messaging, etc. TLS aims to provide a private and secure connection between a web browser and a website server. It does this with a cryptographic handshake between two systems using public key cryptography. The two parties to the connection exchange a secret token, and once each machine validates this token, it is used for all communications. The connection employs lighter symmetric cryptography to save bandwidth and processing power. Since the application layer is the closest layer to the end user, it provides hackers with the largest threat surface. Poor app layer security can lead to performance and stability issues, data theft, and in some cases, the network being taken down. Examples of application layer attacks include distributed denial of service attacks or DDoS attacks, HTTP floods, SQL injections, cross-site scripting, etc. Most organizations have an arsenal of application layer security protections to combat these and more, such as web application firewalls, secure web gateway services, etc. Now that we have the theory behind network security has been covered in detail, let us go through some of the tools that can be used to enforce these network security policies. The first tool to be covered in this section is a firewall. A firewall is a type of network security device that keeps track of incoming and outgoing network traffic, and it decides which traffic to allow or deny in accordance to a set of security rules. For more than 25 years, firewalls have served as network security's first line of defense. They provide a barrier between trustworthy internal protected and regulated networks from shady external networks like the internet at some point. The next tool which can be used to bolster network security is a virtual private network, or VPN for short. It's an encrypted connection between a device and a network via the internet. The encrypted connection aids the secure transmission of sensitive data. It makes it impossible for unauthorized parties to eavesdrop on the traffic and enables remote work for the user. The usage of VPN technology is common in both corporate and personal networks. Next, we cover the importance of intrusion prevention systems in network security, or IPS frameworks. An intrusion prevention system is a network security tool that continually scans the network for harmful activity and responds to it when it does occur by reporting, blocking, or discarding it. It can be either hardware or software. It's more sophisticated than an intrusion detection system or an IDS framework, which can just warn an administrator and merely identify harmful activities, while in the case of an IPS, it actually takes against that activity. The next tool in this section and the final one are going to be behavioral analytics. Behavioral analytics focus more on the statistics that are being carried over and stored through months and years of usage. Once some kind of similar pattern is noted, where the IT administrator can detect some kind of attack, the similar attacks can be stopped and the security can be further enhanced. Now that we have covered all that we need to know about network security, the necessary tools, its different types, etc., let's go to the benefits of network security as a whole. The first, which is protection against external threats. The objective for cyber assaults can be as varied as the offenders themselves. Although they're typically initiated for financial gain, whether they are industrial spies, hacktivists, or cyber criminals, these bad actors all have one thing in common, which is how quick, clever, and covert the attacks are getting. A strong cybersecurity posture that considers routine software updates may assist firms in identifying and responding to the abuse techniques, tools, and the common entry points. The next benefit is protection against internal threats. The human aspect continues to be the cybersecurity system's weakest link. Insider risk can originate from current or former workers, third-party vendors, or even trusted partners, and they can be unintentional, careless, or downright evil. Aside from that, the rapid expansion of remote work and the personal devices used for business purposes, while even IoT devices in remote locations, can make it easier for these kind of threats to go undetected until it's too late. However, by proactively monitoring networks and managing access, these dangers may be identified and dealt with before they become expensive disasters. The third benefit is increased productivity. It is nearly impossible for employees to function when networks and personal devices are slowed to a crawl by viruses and other cyber attacks during the operation of website and for the company to run. You may significantly minimize violations and the amount of downtime required to fix the breach by implementing various cybersecurity measures such as enhanced firewalls, virus scanning, and automatic backups. Employee identification of possible email phishing schemes, suspicious links, and other malicious criminal activities can also be aided by education and training. Another benefit is brand trust and reputation. Customer retention is one of the most crucial elements in business development. Customers today place a premium on maintaining brand loyalty through a strong cybersecurity stance, since this is the fastest way to get other businesses back, get referrals, and sell more tickets overall. Additionally, it helps manufacturers get on the vendor list with bigger companies as a part of their supply chain, which is only as strong as its weakest link. This opens possibilities for potential future endeavors and development.
Ethernet. Ethernet is a form of communication network that uses a wired medium to connect devices for data exchange in a network. For example, LAN, also known as Local Area Network. Also, WAN, known as Wide Area Network. Ethernet also applies different protocol on the data to be transmitted over the communication channel efficiently and smoothly. Moving on, let's look into why to use Ethernet. As we now know, the Ethernet is a mode of connection for multiple devices to share and exchange data. But using this way of transmission also has its benefit. For example, the Ethernet network provides us with a high-speed connection for sharing data. Ethernet also provides the user data with a secure channel for transmission. The data that is transmitted over the Ethernet channel is reliable and has rarely faced any issues at the sender side. Let's move on to the next heading. Now we will look into different types of Ethernet. In general, the Ethernet is divided into three different types. First is the fast Ethernet. This type of Ethernet operates on a twisted pair cable with a data transmission speed of up to 100 Mbps per second. Fast Ethernet connections are used for personal connections or used in companies that require low internet connection. Moving on, we have Gigabit Ethernet. This connection is used for high-speed internet connection with a speed ranging from 1000 Mbps to 1 Gbps. It is an upgraded form of fast Ethernet. And the last type is switched Ethernet. This Ethernet type installs network devices such as switches or hubs so as to improve the network transmission. The transmission range for switched Ethernet connection is around 1000 Mbps to 10 Gbps. Now let's look into the working of Ethernet. Ethernet services specifically work in the first layer of the OSI model, that is known as the physical layer, and the second layer of the OSI model, also known as data link layer. Functioning of the Ethernet can be divided into three different parts. First step being acquiring the physical address, that is MAC address, media access control address of the sender and the receiver device. Then the second step is to check the data security, quality of the data, and the connection speed of the transmission channel for efficient and smooth transmission of data over the network. And the last step is to check network traffic and detect any error that occurs in the communication channel. To solve these issues, if occur, CSMA protocols and other protocols are used. For example, the CSMA protocol is used in case of packet collision in the network channel. Now let's look at a simple Ethernet model for further clarification of the steps. But before we begin with the model, the point to be noted is the transmission of data over the Ethernet channel is divided into two parts, frames and packets, where packets represents a unit of data in the network, whereas frame refers to a collection of data packets being transmitted over the channel. And the application of Ethernet services, which includes security, traffic check, and protocols being applied on the data. And that is when it reaches the receiver end. Moving on, let's look into advantages and disadvantages of using Ethernet. For advantages we have, cost of installing Ethernet connection is low in comparison to other network channels. The security of the data being transmitted over the Ethernet channel is maintained. As for disadvantages we have, it is suitable only for establishing short distance communication network due to high requirement of hardware resources. Whereas Ethernet is also not suitable for sharing real-time data and information. Let's look into some more advantages and disadvantages. Ethernet is suitable for maintaining the data quality of the information being transmitted. It also provides high-speed data transmission option for the network. For disadvantages we have, the network traffic issue is a drawback of installing Ethernet cables. Troubleshooting faults and issues in the Ethernet cable is also a troublesome work. Now let's move on to the last heading for this topic, that is Ethernet versus Internet. The first difference is connection medium. For Ethernet connection, physical cables are required. That means it uses wired medium for connection. Whereas in case of Internet, it uses wireless medium such as satellites as a connection medium. Moving on, the next difference is network model. The Ethernet is available only for a low distance connection, for example, LAN, whereas Internet is available for all the network connection distances, be it LAN, MAN, or WAN. Let's move on to the next difference, that is network control. For Ethernet, the complexity of the connection medium is low due to the less distance it uses, and also provides much efficient transmission of data over the communication channel. Whereas for Internet is a large collection of networks and hence require large group of administrator for control. The last difference between Ethernet and Internet is network security and reliability. Ethernet connection is a secure network from external interference and provides data security. Whereas in case of Internet, it is an open type of connection, so it is more prone to hacking attempts and less secure network.
Two major types of network that should be considered basic knowledge for someone starting out with networking: LANs and WANs. The first variety of networks is a local area network, also known as LAN. It comprises of cables, gateways, switches, routers, and additional parts that allow these devices to connect to private servers, cloud services, and other LANs via larger networks. The growth of virtualization has also sped up the creation of virtual LANs, which let network managers divide and logically organize network nodes without having to make significant modifications to the infrastructure. The computers in each department could be conceptually linked to the same switch in an office with many departments, be it accountancy, IT support, and administration. Still, they might be segregated to operate separately. The benefits of a LAN are similar to those of any collection of connected devices. They may access and even control one another, exchange files, print to shared printers, and utilize a single internet connection. To better understand this logic, let us take a sample structure. We can see the various components of a local network connection in this picture. And now we can see three different devices: a system, a laptop, and a printer. So we have these few devices that need to be connected to a single local area network. Now, to identify these devices inside the network, we need to assign an identifier to each device. So this is where an IP address can help. An IP address is a lengthy string of digits allocated to any device connected to a network that utilizes Internet Protocol as the communication medium. It's the digital equivalent of your house or workplace's mailing address. The addresses are divided into four sections separated by dots. Each traditional base 10 numeral portion represents an 8-bit binary integer which can range from 0 to 255. These four integers are expressed in normal decimal notation and then separated by dots. However, computers work with binary numbers, meaning zeros and ones, and each number in an IPv4 address represents an 8-bit binary integer, which is why none of them can be more than 255. The distribution of these IP addresses is not just limited to LAN. Every device which is a part of a network will have its own IP address as assigned by the network administrator. As seen in the picture, we can now identify each device individually by their designated IP addresses. Now, with the primary purpose of a network being the ability of multiple devices to communicate and exchange information with each other, These IP addresses serve only half the purpose, since allotment and identification of these addresses need to be managed automatically and on demand. If the laptop shown on the left of the screen wants to use the printer in the network, it needs to know which particular device, or more precisely, which particular IP address to communicate with. This is where a switch comes into play. It takes the role of the delegation of commands in a particular network. Let's learn more about switches in detail. A network switch joins devices in a network, such as computers, printers, wireless access points, and allows them to communicate with each other by exchanging data packets. They can be both physical hardware devices that handle real networks or software-based virtual devices. The vast majority of network equipment in modern data networks are switches. They link desktop PCs, access points, automated equipment, and some IoT devices via wired connections, such as card entry systems. They link the computers in data centers that run virtual machines or VMs, as well as the actual server and most of the storage equipment. Based on the type of switches employed, they can either differentiate between network devices using either the IP addresses or MAC addresses, which are separate types of addresses allotted to each hardware device, irrespective of the network it is connected to. Now that we understand the major parts of a local area network, a major query that may come to your mind is how can these local networks then communicate with other networks? A router is employed at the forefront of every network setup to facilitate communication between foreign networks. This router can then be used to connect to the internet so we can communicate with the loved ones from the comfort of our own homes. So let's learn a little more about routers. The router is a physical or virtualized internetworking equipment that receives, analyzes, and transmits data packets across computer networks. The router checks a data packet's destination IP address and utilizes headers and forwarding tables to determine the best path to transport the packet. Consider the router to be an air traffic controller and data packets to be airplanes flying to various airports or networks in this case. Each package, like each jet, has a unique destination and must be steered to its destination as effectively as possible. A router helps direct these data packets to their intended IP addresses in the same manner that the air traffic controller ensures that flights arrive at their destination without getting lost or experiencing severe disruptions. A router employs an internal routing table, which is a collection of pathways to multiple network destinations to properly direct packets. It scans the header of a packet to establish its destination, then consults the routing table to find the most efficient way to their destination. The packet is subsequently sent to the next network along the route. A router also has an IP address, which is often called as the network gateway. A crucial part of the networking setup is determining whether a particular piece of hardware is a part of local network or a foreign device. As you already know, specific IP addresses exist for each device in a network, be it a local or wide area network. All these IP addresses must belong to a particular range of addresses, which are often known as the subnet or subnetwork, and which help determine the overall range of a local area network. For example, the IP addresses that can be seen on the screen right now belong to a subnet that is 255.255.0.0. The first two flags denote fixed values that must be present in every single IP address of every single device in this particular network. In our case, the 192.168 is the consistent factor in every single IP address shown on the screen. This implies that if the devices can connect to a piece of equipment with an IP address and it starts from 192.168, that device will most likely be in the same local area network. The last two places are the free ranges in this example, which means they can be any number less than 255, further helping the router and switch differentiate between multiple IP addresses in a network. With that being said, we can now take a look at how wide area networks work. A wide area network, or a WAN, is in its most basic form a collection of local area networks or any other networks that interact with one another. A wide area network is essentially a network of networks, with the internet serving as the world's biggest one. However, when a router communicates with devices outside a local network, it tends to mask the internally allocated IP addresses and uses a single public IP address for all the devices. This process is called network address translation or NAT IP allocation. A network address translation is the method of translating one IP address to another while these packets are in transit through a router. This improves security and reduces the number of IP addresses required by a company. Once a router receives some particular information that must be transmitted to a local device in the network, it checks the internal routing tables to determine the correct internal IP address and the correct destination to send the externally received data to. But let's say a device from the external network or a wide area network wants to communicate directly with a device from the local network. This cannot be allowed since this can be a very big security risk for devices in a secure environment. All of this entry and exit rule creation and handling can be taken care of by a firewall. A firewall is a type of network security device that analyzes the incoming and outgoing networking traffic and allows or denies data packets depending on a set of security rules. Its objective is to provide a barrier between your local network and external traffic, such as the internet. The most common sort of firewall, which are packet filtering firewalls, check packets and prevent them from getting through if they do not meet an established security rule set. This sort of firewall examines the packet's destination and source IP addresses. If the packet fits an allowed rule on the firewall, they are permitted to access the network. But let's say we, as users, want to allow external requests to reach individual computers or devices on our local network. There are two ways to facilitate this behavior. The first way to go through this step is by using a DMZ, which stands for a demilitarized zone. Instead of communicating directly with the local network device, the external data is sent to the router instead. The router will have created a DMZ subnetwork with only those devices added to it that require the external information to reach them unaltered. Once the data is received by the router, it passes it on to the DMZ subnet and subsequently to all the devices which are a part of that subnet. However, since the external data can reach devices in a network without any firewall checks if they are part of the DMZ subnet, the security risks associated with this method are very large compared to the second variant, which is port forwarding. Port forwarding is a method of granting external devices access to computers on private networks. It accomplishes this by translating an external IP address and port to an internal IP address and port. All the devices talk to each other and the network gateway using the IP addresses and specific ports. For example, the TCP/IP protocol, basic internet usage, uses port 80 on every network. Similarly, we can create additional firewall rules to open up certain ports for external devices to communicate with. If the designated ports are open during communication, the firewall will allow the external network device or server to communicate directly with the local network device without any hindrance. That's all we really need to know for now about the basics of networking.
Then let's begin with the first heading. What is network topology? It is referred to as an arrangement of multiple systems and network devices interconnected to each other through a physical medium or logical channel. The term network topology is a combination of two individual network concepts. First is the network part, which represents the devices or systems that are also known as nodes, which is connected and how to change the data within the network. Then the other part is topology, which represents the connection medium between different network devices and governs the data flow between them. Moving on, let's talk about why do we apply the concept of network topology. For the first point, it allows the users to understand the overall model of the network along with the number of devices installed and their positions in the network, which provide ease of installation of security measures and network and helps in case of troubleshooting cases. Then, for the next reason, applying network topology helps the user to understand the communication relationship among the different devices and through a connection medium. This in turn helps the network professionals to set up an optimal network unit for the user. Next in the list, we have different types of topologies used in networking. First is the bus topology, then we have ring topology, then star topology, then tree topology, and in the end, mesh topology. But to understand the concept of topology, let's start by point-to-point topology. This is simplest form of topology connection which consists of two nodes connected through a connection medium like a network cable. The nodes at the two ends of the cable shares data information between them, where the data sharing part represents the network and the cable connection is the topology part. With this, we have understanding of network topology. Then let's begin with complex types of tech connections. First is the bus topology. In this topology, the connection channel is a single cable known as the network backbone, through which all the other nodes are connected to. In this network setting, the data packets sent by the nodes are provided with the receiver address to avoid transmission errors. The data in this topology can travel from any endpoint where they are termed as terminate points. Advantages of bus topology. It is easy to set up due to the simple configuration settings. This setting is also cost effective as it requires only a network cable for the connection. In the case of crash node, the whole network remains unaffected as it does not have any direct connection to the other node. Let's take a look at disadvantages of bus topology. In case of troubleshooting, we require the use of special equipment to detect the fault in the network. In the case of multiple data transmission, the packet collision is the frequent occurrence, damaging the transmitted message data due to the unavailability of network devices such as switches, repeaters, etc. The loss of data over long distances communication is quite high. Then, ring topology. As the name suggests, the nodes in the network are connected in a circular pattern similar to a ring. The data transmitted in this connection is always in the clockwise direction. The topology does not have any termination point due to its ring structure. The method of data transmission is known as token passing, which involves sending a token along with the data packet to which each of the node matches to identify the destination node using the destination address in the token. Next, advantages of ring topology. The crash node can be easily removed from the network. The configuration settings are not complex for setup and materials are easily accessible. The cost of installation is low as no extra network devices are required to the connection. Moving on, we have disadvantages of ring topology. In the case of a node crash, the whole system is affected and is non-accessible due to the direct connection of each node. The transfer of data is slow due to the token passing method in the network. Difficulty in the troubleshooting fault in the connection leads to the crash of the whole network. Now let's talk about star topology. In this topology, the networks are connected to each other through the central hub, which can be a computer or a server. The central unit in the connection is also known as the server and the nodes are known as the clients. Any connection between the nodes has to be through the server and is one of the most popular topology connections. Next, advantages of star topology. In case of a node crash, the network as a whole remains unaffected as each node is connected to the server of a connection. The hardware requirements are easily available and of low cost. Troubleshooting is easy through the use of central hub to identify the faulty node. Disadvantages. In case of a server failure, the whole network is shut down as all nodes are interconnected through the server. The connection configuration is complex due to the pattern of the topology. Next up, tree topology. This topology is a combination of star and bus topology. The node connection in the topology follows hierarchical pattern, with the topmost node as the root and the branching nodes as the child node. The sharing of data is from the root node to the child node pattern. Next up, advantages of tree. Installation of a new network group is easy due to the root-child configuration of the network. In case of a node fault or crash, the whole network is not affected by the error. This makes it easier to troubleshoot the issue. Next up, disadvantages. In case of a server crash in any of the star connection groups, the whole network is affected. Due to the complex setting of the topology, installing security points is difficult in the network. Configuring and troubleshooting internal issues is quite complex due to this topology. Next up, mesh topology. As the name suggests, this topology is a connection of interconnected systems connected to each other in no particular order. No installation of network devices such as switch or hubs. This topology pattern can be divided into two forms. First is full mesh topology. In this connection, all the nodes are connected to each other in the network. Then we have partial mesh topology, where all of the nodes are connected to each other available in the network. Let's talk about the advantages of mesh topology. In case of a node damage, the whole network does not suffer from the fault. Due to the interconnected patterns of the connection, the transmission of data is very high in the network. Next up, disadvantages. The cost of installation is high due to the requirement of multiple cables and nodes for the network to function efficiently. The management of the network becomes complex due to the large number of interconnections in the network. Due to the absence of repeater or a switch, the data signal loss during the transmission is very high. Now, let's take a look at how to choose best topology for a network configuration. First up, cost. The installation cost is one of the biggest factors that affects the type of topology configuration we choose from our network, as the cost of installing cables, routers, switches, and other network connections is low. Then we have easy installation. Installing the hardware devices efficiently and precisely is also one of the factors that affect our choice of network topology. Moving on, we have flexibility. The ability of the topology to include new network nodes after installation and ease of troubleshooting refers to the flexibility of topology. In the hand, we have reliable security. It is important that the topology installed allows us to introduce proper security points in the network and leading to fewer crash cases. By referring the above factors, we can decide the best topology for our network.
To better understand the OSI model, let's take a look at a scenario. Assuming we have two different systems with different operating systems installed in them, and there is a communication channel between them over which the data is shared. But sometimes during transmission of data, it faces some problems. These errors often arise due to the different operating system installed in the system or due to a network problem during a transmission. But to overcome such situations, the OSI model structure is used. Using the OSI model structure, we can make the transmission of data over the communication channel error-free. Let's take a look at the definition for the OSI model. The OSI model stands for Open System Interconnection Model, or a specifically designed set of protocols and standards that governs the modeling and conversion of the data for proper transmission over the network channels. The OSI model is based on the layer structure, where it consists of 7 different layers, where each layer has different set of protocols that are to be applied on the data during the transmission over the network channel. Let's take a look at the different layers of the OSI model. The OSI model consists of 7 different layers which perform specific functions and apply different protocols at different layers to maintain the quality and prevent the data from getting corrupted when it is transmitted over the communication channel. Let's take a look at each of them. The first layer is known as the application layer, which is the topmost layer. Then we have the presentation layer, session layer, transport layer, network layer, data link layer, and physical layer, which is the last layer of the OSI model. The upper 4 layers in the OSI model represents the host layers. That is, they interact with the application related issues when the data is transmitted over the communication channel. Whereas the lower layers are termed as network layers. They specifically deal with the transmission related steps for the data over the network channel. Let's take a look about some information in regards to the layers. Now let's take a look at the function and the data format that is handled by each of the layers during the transmission of data. The first layer is the application layer. which interacts as a gateway for the host data and network applications and handles the data format. Then we have the presentation layer, which handles the initial step towards the conversation of data for transfer. It also handles the data format. Then we have the session layer. Session layer establishes a connection between the network devices for the data transfer. Then we have the transport layer, which oversees the data that is transferred without any error and is in the same pattern needed by the destination system. The data format handled by this layer is segment format. Next, we have the network layer, which determines the path for the data transfer. It handles packet related data. Then we have the data link layer, which performs the task of connecting the physical nodes for the transfer of data. It handles frame data. And in the end, we have the physical layer, which is used to transfer the raw bits, that is, in terms of ones and zeros, over the physical mode. Now that we are clear about different layers that are present in the OSI model and some information regarding them, let's take a look at each of the layers in detail. We'll start with top to bottom. That is, the application layer will be the layer that we'll be starting with. Let's take a look. The topmost layer in the OSI model is the application layer, which acts as an interface between the user and the applications that are being accessed, which can be Internet Explorer, Chrome, or any email client. It also handles different protocols that are needed for the data transmission over the network channel, which can be given as Hypertext Transfer Protocol, the HTTP protocol, and the SMTP protocol, which is the Simple Mail Transfer Protocols. Now let's move on to the next layer. The next layer is known as the presentation layer. The presentation layer is responsible for performing conversion tasks over the data that is received from the application layer. The conversion of data is done in accordance to the required format. It also performs encryption over the converted data so as to prevent it from getting hacked by cybercriminals or hackers. The compression of the encrypted data is also performed by the presentation layer so that it can be passed on to the session layer. The next layer in the OSI model is known as the session layer. In this layer, the communication channel between two different devices is established. The network devices are individually known as session. The data that is transferred is to be done over these session channels. The layer that is the session layer establishes and terminates these sessions in case of an error or some other unforeseen event. This layer is also responsible for authentication checks regarding the data that is being transferred and also provides data recovery options in case an error occurs over the communication channel. Some model layers, let's take up a question. The question is, what is the main action that takes place at the presentation layer? And the options are, first option, data segmentation, second option, encryption of data, third option, framing of data, and the fourth option, bit conversion of data. You can provide your answers in the comment section below. Let's move on with the next layer. The next layer in the OSI model is known as the transport layer. The main task performed by this layer is to break the data that is received from the session layer into different segments. These segments comprises of protocols which are UDP protocol and TCP protocol along with the data that is segmented from the received data. Then the segmented data along with the UDP and TCP identification is transferred over to the transmission channel, where then it's further transferred to the network devices that requested for the data. This layer also performs a very crucial part, which is the flow control. Let's understand flow control over the network channel through a small example. In this example, the server has a capacity to send 50 Mbps of data at once, whereas the receiver side has a capacity for 10 Mbps. When the data is transferred from the server to the client, it transfers 50 Mbps. But it isn't possible to transfer all this data at once due to the lower capacity on the client side, which is why the flow control changes is required, which is provided to the server side by the transport layer. Now let's move on to the network layer, which is the third layer from the bottom in the OSI model. This layer is responsible for breaking down the segments into data packets by adding IP address to them that is received from the transport layer. These data packets are then further transmitted over through the best possible route to the destination system, which are governed by the Internet protocols, including IP and IPv6 protocols. For example, if we have a data that is to be transferred to the network device 2, we choose the best option, that is the route to be transferred over to that network device. Now let's move on to the next layer in the OSI model, which is a data link layer. This layer is responsible for maintaining and terminating the established connection between the devices over the network. The MAC address in this layer is added to the data packets, which are collectively known as data frames. These data frames are then further transmitted over to the physical network. These are divided into two different sublayers. Medium access control, that is MAC, which controls the established connection device. And the second sublayer is logical link control layer, LLC, which identifies the address and provides flow control for the data. This data frame, as earlier told, is transferred over to the physical layer. Now let's take a look at another question to brush up whatever we learned so far. The question is, which layer includes the MAC sublayer in the OSI model? Option 1, application layer. Option 2, session layer. Option 3, data link layer. Option 4, transport layer. You can give your answers in the comment section below. Let's move on to the last layer in the OSI model, which is a physical layer. This layer is responsible and provides the physical medium over which the data frame is transferred. But the transfer data is converted into bits before it's transferred. The transmission of data is covered by different protocols that are embedded in the physical layer. The transmission of ones and zeros format data is done. It also is responsible for maintaining the data quality by applying different necessary protocols and maintaining the bit rate throughout the transfer of data, whether it be wired media or wireless media. Firstly, we'll understand what exactly is the model. The TCP/IP model is a method of sharing data and information over the communication channel, where the data has to go through each of the four layer structure of the network model, where it also performs tasks such as remodeling of data, efficient transmission, and error-related issues. Each layer has dedicated protocols that they enact on the transmission data. Now let's continue with the protocols that are used in the TCP/IP model. To understand the protocols that are used in the TCP/IP model, we'll compare it with the OSI model. And if you want to know more about the OSI model, you can visit our video on the Simplilearn channel. Let's begin. The topmost three layers of the OSI model, which are application layer, presentation layer, and session layer, collectively refers to the application layer in the TCP/IP model, where they use protocols such as FTP, File Transfer Protocol, HTTP, Hypertext Transfer Protocol, Telnet, and SMTP, which is Simple Mail Transfer Protocol. Then we have the transport layer from OSI model, which refers to the transport layer in the TCP/IP model, where they apply protocols such as TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. Moving on, we have network layer from the OSI model, which refers to the internet layer in the TCP/IP model, which apply protocols such as IP, Internet Protocol, ICMP, Internet Control Message Protocol, and ARP, Address Resolution Protocol. Then we have data link layer and physical layer from the OSI model, which refer to the network access layer in the TCP/IP model. These layers doesn't exactly apply any protocol but are connected through physical medium, which includes Ethernet, Wi-Fi, and cables. Now that we are completed with the protocols regarding TCP/IP model, let's take a look at the layers in detail. The TCP/IP network model consists of different layers, where the original model consists of 4 different layers, which are application layer, transport layer, internet layer, and network access layer. Then we have the updated model, which consists of layer, application layer, transport layer, internet layer, data link layer, and physical layer. Let's take a look at the layers in detail. The first layer that we are going to know about is the application layer. Application layer. This layer acts as an interface between the application and programs that require the TCP/IP model for communication, including tasks performed by the layer, such as data representation for the software application that are executed by the user and then forwarded to the transport layer. The protocols supplied by this layers are HTTP, Hypertext Transfer Protocol, which is used to access information available on the internet. Then we have SMTP, Simple Mail Transfer Protocol, which is used to access email-related tasks. Moving forward, we have the transport layer. This layer is responsible for establishing connection between the sender and the receiver device. This layer performs the task of dividing the data from the application layer into packets, where they are used to create sequences, which are then transferred over to the destination device. It also performs the task of maintaining the data, that is, to be transmitted without error, and controls the data flow rate. The protocols that are applied in the transport layer are TCP, Transmission Control Protocol, which is responsible for transmission of segments over the communication channel. Then we have UDP, User Datagram Protocol, which is responsible for identifying error in the data that is to be transmitted over the communication channel. Moving forward, the next layer is the Internet layer. This layer is responsible for the transmission of data over the network channel. That is, they provide a proper route for the packets to be transferred over the communication channel. The protocols that are applied by this Internet layer are IP protocol, which is the Internet protocol. This protocol assigns a unique address to a physical system so that it can be identified on the Internet. Then we have ARP, Address Resolution Protocol. This protocol is used to find the physical address of the system using the Internet Protocol address. In the end, we have the network access layer. This layer is a combination of data link layer and physical layer from the OSI model, where it is responsible for maintaining the task of sending and receiving data in raw bits. The raw bits are transferred from the sender side to the receiver side in the format of binary digit, which are zeros and ones. Let's move on with the advantages of using the TCP/IP model. The TCP/IP model assigns an IP address to each of the system that is available on the network channel so that they can be identified on the internet. Then they are also responsible for enacting different protocols on the data that is to be transmitted over the communication channel. The TCP/IP model also enables the user and the system to access different format of data over the communication channel. Now let's take a look at the last topic for this session, which is the OSI model versus the TCP/IP model. On comparing both of the network models, we get the OSI model consists of 7 different layers, whereas the TCP/IP model comprises of 4 different layers. The OSI model has separate session layer, presentation layer, whereas the TCP/IP model comprises of a single application layer. The transport layer in the OSI model provides packet delivery protocols, but in the TCP/IP model, transport layer does not provide any such protocols. The OSI model is implemented during network communication, but in case of TCP/IP model, it is used as a reference model for the network channel.
If you are someone who is interested in building a career in cybersecurity or a networking professional by graduating from the best universities, or a professional who elicits to switch careers with networking by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in cybersecurity with modules from MIT Schwarzman College of Engineering. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
Introduction to Network Protocol. A network protocol is like a set of rules that govern how devices in a network communicate with each other. These rules are like instructions that specify how data should be sent, received, and understood by the devices. Network protocols are formalized requirements and plans that consist of rules and procedures that describe how devices should interact with each other over a network. They provide a communication system to exchange information using various physical means such as cables or wireless connections. Just like humans follow certain protocols when they interact with each other, network protocols define specific steps and guidelines for devices to follow. These rules ensure that information is sent and received correctly and that all devices involved understand each other. In essence, network protocols are a way for devices to speak the same language and follow a common set of guidelines so that they can successfully share information and work together effectively. Now let's understand the need of network protocols. Alright, so let me explain this to you in simple terms. Network protocols are like guidelines that devices follow when they communicate with each other over a network. These protocols are needed for several reasons. Firstly, network protocols ensure that devices understand each other. Imagine if you and your friend were speaking different languages and had no way to understand each other. Communication would be impossible. Similarly, devices from different manufacturers and with different functions need a common language or protocol to understand each other's signals and data. Secondly, network protocols ensure that data is transmitted reliably. When you send a message or a browser a website, you want to make sure that the information reaches its destination accurately and without errors. Network protocols help in breaking down data into smaller packets, sending them across the network and reassembling them correctly at the receiving end. Thirdly, network protocols provide security. They include measures to protect data from unauthorized access and ensure that sensitive information remains confidential. This is particularly important when you make online transactions or share personal information over the internet. Lastly, network protocols allow for interoperability. This means that devices from different manufacturers and with different functions can work together seamlessly. For example, your computer can connect to a printer and your smartphone can access a Wi-Fi network because they follow the same protocols. So these were some of the needs of network protocols. Now, before understanding the types of network protocols, we must understand about Ethernet. So Ethernet is a type of network protocol that helps devices connect and communicate with each other in a local area network, LAN. It is like a highway that allows data to travel between devices such as computers, printers, and routers. Ethernet uses a set of rules and procedures to transmit data in the form of packets. These packets are like small packages of information that are sent from one device to another. Ethernet ensures that these packets are delivered to the right destination and in the correct order. Think of Ethernet as the root system that connects all the devices in a network. It ensures that data can flow smoothly between devices, enabling them to share information and work together efficiently. Now let's have a look at the types of network protocols. Here we will cover some of the types of network protocols. We'll start with the first one, which is TCP, that is Transmission Control Protocol. TCP is a network protocol that ensures reliable and ordered delivery of data between devices. It breaks down data into smaller packets, sends them across the network, and ensures that they are reassembled correctly at the receiving end. TCP also handles error detection and retransmission if any packets are lost or corrupted during transmission. So this was about TCP or Transmission Control Protocol. Now, second is IP, that is Internet Protocol. IP is another network protocol that handles the addressing and routing of packets across the internet. It assigns unique IP addresses to devices and determines how data is sent from the source device to the destination device. IP ensures that the data packets reach the right destination by routing them through various network devices like routers. Third is UDP or User Datagram Protocol. UDP is a network protocol that provides a faster but less reliable method of data transmission compared to TCP. It does not establish a connection or guarantee packet delivery or order. UDP is commonly used for time-sensitive applications like video streaming or online gaming, where a small amount of data loss is acceptable. Next is POP, that is Post Office Protocol. POP is a network protocol used for retrieving emails from a mail server to a client device. It allows users to download emails from the server onto their device and manage them locally. POP is typically used by email clients like Outlook or Thunderbird. Next we have is SMTP or Simple Mail Transfer Protocol. SMTP is a network protocol used for sending emails from a client device to a mail server. It handles the transmission of email messages and ensures that they are delivered to the appropriate recipient's mail server. SMTP is responsible for the reliable transfer of email across different mail servers. So this was about Simple Mail Transfer Protocol. Now let's understand the sixth one, which is File Transfer Protocol or FTP. FTP is a network protocol used for transferring files between devices over a network. It provides a standard method for uploading and downloading files to and from a remote server. FTP allows users to navigate directories, transfer files, and manage file permissions. Now coming to the next, which is Hypertext Transfer Protocol Secure, that is HTTPS. HTTP is a secure version of HTTP that provides encryption and authentication. It ensures that the data transmitted between a web browser and a web server is encrypted and protected from unauthorized access. HTTPS is commonly used for secure online transactions, sensitive data transfers, and protecting users' privacy. So these were some of the types of network protocols. So basically, network protocols play a crucial role in enabling communication and data transfer across various computer networks. We have explored several types of network protocols, each serving specific purpose and operating at different layers of networking model.
IPv4 addresses. The first version of an IP address to be developed was based on 32-bit binary format that counts roughly around 2 to the power 32 bits of total IP addresses in IPv4 format, which was sufficient at the initial phase of network requirement, but is somewhat lacking according to the current advancement in the network technology. The addresses in this IP ranges from 0 to 225 in terms of zeros and ones, with 4 octets where each of them is separated by a period. This is an example for an IPv4 IP address, where the first 3 parts represent the network ID and the last part represents the host ID. Using the IPv4 address as our reference, we can identify IPv4 addresses from IPv6 addresses. Now let's move on to the next topic, that is IP classes. IP classes are designed to allow easy and efficient assignment of IP addresses to a network. Depending on class size, we have 5 different IP classes in a network that are named as A, B, C, and D. For the first part, we have class A that accommodates network with a large number of network hosts, where the first bit in the octet is always 0 with number value ranging from 0 to 127. Then we have class B, which can fulfill the requirement for a moderate number of network hosts. The lead bit is 1 and 0, and network ID ranges from 128 to 191. Then we have class C, which can allocate an IP address for low number of network hosts, where the first 3 bits of the network ID is 1, 1 and 0, ranging from 192 to 223. Through the above 3 classes, that is class A, B and C, we can easily identify and assign addresses to a network host. Moving on, we have class D, where it is used for multicasting. That means it is used to send multiple signals at the same time from a single host. For example, used in video streaming. where the lead bit is 111 and 0, with network ID ranges from 224 to 239. And then we have class E, where the IP bits for this is reserved for research purpose only, where the IP addresses ranges from 240 to 255. Moving on, let's take a look at some of the features for IPv4 version addresses, where the first is the memory required for storing IPv4 version addresses in a system is very low. Then we have IPv4 version addresses apply connectionless protocol for sharing data and providing the best effort in delivery. Moving on, we have stacking option for IPv4 addresses. That means in IPv4 version, it allows to create a multiple network over a single host, which allows different hosts to connect to it. Moving on, we have IPv4 version addresses being the earliest IP designed are applicable to most of the network devices and system for connecting to the internet. So it is supported by many devices. Then we have IPv6 addresses. Let's take a look. With the increase in the need for an IP address, the IPv4 version addresses are somewhat unable to complete the requirements of the network host. So the need for IPv4 version arose, which is based on a 128-bit address size, which is sufficient for a very long time. That is approximately 320 undecillion IP addresses in version 6. This type of IPv version is designed of 4 hexadecimal digit and 8 sets, with each block containing 16 bits separated by a colon. Moving on, let's take a look at some of the features for IPv6 version addresses. Where the first is IPv version 6 addresses provides an integrated security protocol for the network, that is Internet Protocol Security, IPsec. Then we have it allows its application to extend in various services according to the need of the network. It also allows address configuration through stateful that uses DHCP server for network settings and stateless that applies auto configuration settings. IPv6 addresses also allow some methods to convert IPv4 addresses to IPv6 addresses, which is according to the requirement of the host or the network. Moving on, let's take a look at the differences between IPv4 version addresses and IPv6 version addresses. This heading would allow us to choose a best IP address that we can decide for a network. Let's take a look at the first difference, that is address and performance. In accordance to the address size, IPv4 version is composed of 32-bit address length and is the fourth version of the Internet Protocol. For IPv6, we have the address size is 128-bit long and is the latest version of the Internet Protocol. The second difference is on the basis of address field type. IPv6 addresses are based on numeric data with 4 fields, each separated by a period, whereas for IPv6 addresses are based on alphanumeric type data with 8 fields, each separated by a colon. The next difference is based on address configuration. In IPv4 version addresses, a manual setting for the network is required along with the DHCP configuration settings. Whereas in case of IPv6 version addresses, the network setting is based in accordance to the system's requirement, and it also supports auto configuration setting for the system. Moving on, we have the number of addresses in each IP. In case of IPv4, the total number of addresses are nearly 4 billion addresses, whereas in case of IPv6 version, we have 320 undecillion addresses. Now let's take up a quiz to understand what we did so far. And the question is, Identify the correct form of IPv4 version address in the given options. And the options are, you can give your answers in the comment section below. Let's move on to the next difference, that is address security and functioning. IPv4 version addresses do not provide any security function for the network, whereas in case of IPv6 addresses, Integrated Internet Security Protocol, that is IPsec, is responsible for the security of the network. The next difference is encryption and authentication settings. IPv4 version does not provide any encryption or authentication services for the network. IPv6 addresses do provide mandatory encryption and authentication services for its addresses. Moving on, we have address routing and performance. IPv4 version follows routing protocol, that is RIP, for network configuration and is preferred over IPv6 version. And in case of IPv6, it does not follow any routing protocols and it uses static routes for network functioning. Now that we are completed with the differences between IPv6 and IPv4, we can easily identify the IP address we want to choose for a network. Let's take a look at network sniffing. To access the network related information between devices to gain profit or use the hacked data for illegal purpose is known as network sniffing. This is a process where a hacker or a malicious programmer spy into the network devices of our system. They can access different websites that we visit often or see our network habits. Let's take a look at different tools that are suitable for sniffing purpose. Network sniffing tools are softwares that are available on the internet that can be used to sniff into the network. Let's take a look at some of the famous network tools. First one is OVIC. This is a networking sniffing tool which has specialization in intelligent analysis for network packets. Next is Wireshark. This software tool is best to look into protocol related data packets that are often transmitted over the network. And lastly, we have SolarWinds Network Packet Sniffer, where the performance of this sniffing tool is best where the performance management is to be looked into. Let's take a look at the Wireshark sniffing tool. This is an open source network sniffing software which is specifically designed to attack data packets during the transmission over the network. This type of software uses different color combinations to represent different packets and protocols. Let's take a look at some of the uses for the sniffing software. The first use is it is used to analyze network packets, whereas it can also be used to troubleshoot different network issues which are often used by different engineers to test whether the software or a network device is susceptible to an attack. And lastly, it is also used to check malicious and hacking possibilities on the network. Now that we are completed with the briefing for the software that is known as Wireshark, let's take a look at the actual demo how exactly network sniffing is done. You can directly access the Wireshark software website where you can find the download option and download the most suitable version for your laptop or computer device. After downloading the software, when you install it, you'll get something like this. As we can see, these connections are the connections that are connected to my laptop right now. And the difference in the graph that we can see over here represent the traffic on the network that is present. To much better understand what exactly is going on the network, we can access one of them. Let's access the Wi-Fi network on my laptop. After accessing the network, we can see some packet settings like this. These represents the packet transaction that has been made on my network through the internet. And this is how a hacker or a cybercriminal knows how exactly we use a network services. This part of the Wireshark represents different detailed information about the transaction that has been made. And the last section represents some raw data or garbage data. But how exactly a hacker use all this jumbled data and hack into a system? Well, to clarify this, there's an option that can be used that is known as display filter on the Wireshark software. If you want to search for a specific protocol, for example TCP, we can write TCP in the search filter and search. And now as we can see, we only get the protocols that are related to TCP. This is how we can differentiate different protocols and access some of them to gain knowledge about what exactly is going on in the network. Let's try accessing some other protocol now. For example, DNS. And as we can see, only the protocol and the data packet that is related to DNS protocol is visible to us. To further enhance the display filter, let's try accessing a different page on the web browser. For example, Simplilearn.com. When we access the Simplilearn website, we can see the professional courses that are available. But let's take a look at the changes that has been made on the Wireshark. To know this, let's write TCP and a keyword included contains. And one more thing to include over here is, during the display filter, if you write something that is related to the software, it will represent in a green color, like this. But if you write some error related keywords like this, it will represent in the red. Let's continue with the search setting. Including the contains keyword and writing Simplilearn and entering. Now, as we can see, these two related data packets represent the Simplilearn website that we accessed just now, where the source destination IP address represents my system address, whereas the destination, that is 13.224.21.74, represent the Simplilearn's IP address. Let's take a look. And in the garbage area or the raw data, we can take a look Simplilearn website. To see some more details regarding the same, you can access the transport layer security and the transmission control protocol, where we can see the source port, the destination port, which is always 443, as well as the flag and the timestamp for the same. This is how hackers get the data about a network settings. But if we want to search for more data related to Simplilearn website that we visited just now, there's another filter that we can use. For example, using ip.addr space equal equal and writing the IP address for the website Simplilearn, that is 13.224.21.74. And when we press enter, we get all the related data for the Simplilearn website. And this is how we can see the related data. To much further enhance our display settings, let's try another example. Access your internet browser and access some other website. For example, the State University, and access the Allahabad State University and some other partnet, for example, the University State PDF. Let's see the changes in our Wireshark settings and try using HTTP. When we write this, we get the data that is related to the HTTP. But what is the use for the same? When you access this and right click on the same and choose the option follow and HTTP stream, and over here we can take a look at the host that is the website that we just visited. Now imagine if we were a hacker and we knew all this. We can access any website that a user visited and we can hack into his system through the website. Guys, but the point that has to be noted over here is, if we use the network sniffing tool, Wireshark, or some other tool that is available on the internet for research purpose or experimental use, that's fine. But we shouldn't use all these softwares for any malicious activity because that is illegal. Now, some of the options that we can see are the red box. This action is used if we want to stop the traffic connection. That means if we press this option and clear this and press enter, this shows that the network settings has stopped receiving any traffic that is available on the network. But if we want to access them again, we can choose this bluefin option, continue without saving, and the software again start recording the websites or the data packets that are available on the network. Now let's take a look at an example. As we all know, we often visit different websites, and there are some cases we often see when the Chrome represents a non-secure option. That represents that the website is unprotected against network attack. For example, we can access an experimental website. This is a website that allows us to access the non-secure part of a website. If we write for username as admin1213 and for password as Simplilearn, and login. As this is an experimental website, it says it's sorry and the login has failed. Let's see the changes in a Wireshark software. Now, as we already did earlier, if we want to access a specific website, we should write TCP contains and the keyword of the website, that was admin. Through this, we can see this was the website that we visited just now. But if we want to access the actual important data, that was the password that we typed, we can use this option. And over here we can see the Simplilearn, which was encrypted earlier in the website. This is how a hacker or a cyber criminal use different sniffing softwares and gain data about different users. And with this, we have reached the end of the session. What is subnetting? The process of subnetting is to divide the network into smaller network parts. This allows the system to have better connectivity in the system. It also increases the security measures for the network against hacking attempts and also maintains an efficient flow of network traffic. The smaller divided units of the network are known as subnetworks. Taking an example of an IP address with /24 representing the subnet mask can be divided into two subnetworks of /25 subnet mask, which can further be divided into smaller subnetworks. Now that we understand what is subnetting, let's move on to class addresses and subnet mask. Firstly, let's begin with class addresses. To better understand the subnetting process, we need some information regarding different classes used in IP address, where the first class is class A with a range of 0 to 127, network bits as /8. Then we have class B with a range of 128 to 191 with network bits as 16. And lastly, we have class C with network range of 192 to 223 with network bits as 24. The network bits representing each class are very important when making subnets of a particular IP address. Let's see how they do so. For this, we'll be representing each class in binary format. For class A, we have 1 for 8 bits. for class B 16 bits, and class C 24 bits. Moving on, we will see what exactly is the subnet mask. To better define the subnetworks in the system, we require the use of a subnet mask. That is, the subnet mask is a way to differentiate between the portion of an IP address that represents the network address ID and the host network ID. In this, let's see the default subnet mask for each of the class. For class A, we have 255.0.0.0. For class B, we have 255.255.0.0. Whereas for class C, we have 255.255.255.0. To better understand this, let's take a look at the classes individually. The network ID part is the one that represents the binary digit 1, whereas host ID represents binary digit 0. That means for class A, we have 8 bits as network ID and the remaining bits as host ID. By looking at the host ID, we can see that the network addresses that are available for the host is the largest in the class A. Whereas for class B, we have 16 bits for network ID and the remaining for host ID, where we can see the remaining part for the host ID is lesser than class A. That means class B can assign network IDs for a medium level company. And lastly, for class C, we have 24 bits as network ID and the remaining for host ID. From this, we can see that the host ID used for class C is the lowest. That means only smaller division companies can use class C. Moving on, let's take a look at the characteristics of the subnetting process. First is the network ID, which represents the first IP address in each subnet block. Then we have broadcast ID, which indicates the last IP address of the subnetwork block. Moving on, we have first host ID, which is the immediate first IP address after the network ID. Then we have last host ID. As the name suggests, it defines the IP address before the broadcast ID. Continuing, we have next network ID. This defines the network ID of the next subnet block. Then we have the total number of IP addresses in the subnetwork block. And lastly, we have subnet mask or CIDR, which represents the network ID and the host ID part in an IP address. To better understand all the attributes of the subnetting, let's take a look at an example. In this example, we are assuming an IP address 192.168.0.x with a subnet mask of 24. For this IP address, we have divided it into 4 parts that represent /25, /27, /27, and last part as /26. Now let's find out the details, that means the attributes for the subnetwork /25. The first attribute is the number of IP addresses. Going by the table, we have 0 to 256 addresses in a single block. But in this, /25 represent only 0 to 128. That means the total number of addresses in /25 subnet block is 128. Moving on, we'll find out subnet mask or CIDR. That is the default subnet mask of class C, which I have taken reference from the subnet table which was explained in the earlier slide, which is 255.255.255.128. Then we have the network ID, which represents the topmost network address in the subnetwork block. In our case, it is 192.168.0.0. Then we have broadcast ID, which is the last IP address in any subnetwork block. In our case, it is 192.168.0.127. Moving on, the network ID and the broadcast ID addresses cannot be assigned to any network device in the network, because the network ID is used to identify the subnetwork block in a network. along with the broadcast ID, which is used to communicate with any of the hosts that is connected to the subnetwork block. That also means that the total number of usable network ID addresses in a network block is total number of IP addresses minus 2, that represents network ID and broadcast ID. That would be 128 minus 2, and we get the value 126, which represents the total number of IP addresses that are usable. Moving on, the next attribute is first host ID. That means the first ID after the network ID, which is 192.168.0.1. Then we have the last host ID, which is 192.168.0.126, which is just before the broadcast ID. And lastly, the next network ID, which is 192.168.0.128. Now that we are clear about all the characteristics of our subnetwork, how about a practice round for everyone to find all the characteristics for the subnetwork block /27 subnet mask? You can give your answers in the comment section. Let's move on to the benefits of using subnetting, where the first benefit is enhanced network efficiency. Through the use of applications of subnetting, we can share data to not only a specific portion of the network model, rather than broadcasting to the whole network, causing unnecessary traffic in the channel, as shown in the example. Over here, we see 4 different hosts, and if we want to share specific data to only 2 of the hosts, we can subnet them into specific parts. Through this, the router will only send data to the specific portion of a subnetwork rather than broadcasting to the whole network channel. This will prevent network traffic. Moving on, the other benefit of using subnetting process is network security. Subnetting also provides protection to an extent against any hacking attempts made on the network model due to the complexity of the subnetworks as presented in the example. During the hacking attempt, if we can identify how the virus attacks the network model, we can prevent it from attacking all the subnetworks by compromising a single or 2 of them and preventing the remaining subnetworks. Let's move on to the drawbacks of using subnetting process. The very first drawback of using the subnetting process is it makes the network model much more complex, which in turn affects the maintenance and efficiency. Then we have the unused IP addresses, which are left over from applying the network model in a subnetwork process. And lastly, we have the low efficiency use of hardware devices. If the hardware devices such as router or switches used are of low efficiency, the performance of the subnetwork. What are switching techniques? Switching techniques are network techniques responsible for overseeing the transmission of data over different communication channels. They are also responsible for choosing the best route for data transfer. Next, we will look into why to apply these switching techniques. Using the switching techniques, we can choose the best and the most efficient route for data transfer in the network. For example, if we want to send some data from node A to node B, we can do so by moving from node A to a switch, then node D, then to node B. But doesn't this seems like too long? This is where the switching techniques plays its role. Using the switching technique, we can choose the smallest and the most efficient way, that is node A, switch, then to the node B. Next, we will look into different types of switching techniques. Switching techniques can be divided into 3 primary types. The first is circuit switching, that requires a predestined path for data transmission. Then we have message switching, which integrates the destination address with the data for transmission. And in the end, we have packet switching that divides its message into smaller units known as packets. Packet switching can further be divided into two different types that are virtual switching and datagram switching. Now let's look into some details regarding each of the types. On the first note we have circuit switching. In circuit switching, for data transmission to occur, a pre-established path is required between the sender and the receiver node. For example, assume that we call someone. Then this request is sent over to the network switches, and a route is to be established for the signal to pass through. After the system assigns a route for the signal to pass through, then the receiver receives the call from the caller side. This is how it works. Now let's look into some points to remember about circuit switching. For circuit switching, we require a dedicated channel established between the source and the destination node for the network to pass through. The data transmission can take place only after the path is established. And the last point to remember is, other than the sender and the destination node, no node can interfere with the transmission of data to the established route. Let's look at some advantages and disadvantages of applying circuit switching in a network. For first one, we have advantages. Data transmission in circuit switching is sure to be established due to the predestined path. Circuit switching is preferred for long and continuous transmission of data due to the pre-established path route. Then let's look into some disadvantages. The time required to establish the connection is quite long due to the time required to establish a path. Also, due to the continuous transmission of data in circuit switching, more bandwidth is required for maintaining the connection. Let's move on with message switching. In message switching, no predestined path is established between the sender and the destination node in the message. This technique integrates the destination address into the data transmitted and is shared over the network. Let's look into the setup to better understand the working of message switching. For first step, the sender node integrates the destination address into the message. Then the whole message is transmitted to the switching node in the network, where it gets stored for the next transmission. And similarly, like the second step, this transmission of data is done over the whole network. And finally, through the destination address in the data, it reaches the receiver node. This is how the message switching works. Let's take a look at some points to remember about message switching. In message switching, no predestined path is established. It uses dynamic routing as the message is transmitted through the communication channel in real time. Each node in network switching stores the data unless it is transferred over to the next switch node. Let's take a look at some advantages and disadvantages of applying message switching. To begin with, let's take a look at the advantages. The size of the data that can be transmitted over message switching is variable. In message switching, the use of bandwidth is done in an efficient manner. Now let's look into some disadvantages. For message switching, the nodes that are known as the switch node is to be provided with sufficient storage memory. There is a delay in reaching the destination due to the message technique, that is, the message has to stop at each of the switch node before it is transferred over to the destination node. Now let's look into the last switching technique, that is packet switching. In packet switching, the message is broken into smaller data units known as packets. These packets are appended with relevant network details for the transmission over the network. let's look into the working of packet switching. We know that in packet switching, the data is broken into smaller units packets, which each packet is given a sequence number for identification. These packets are integrated with required sender and receiver address and switching method to choose the smallest route to reach the destination node. These packets are then recombined at the destination node in the correct sequence order. Now let's look into some points to remember for packet switching. For packet switching, all the data packets that are provided with unique number for identification at the receiver end, that is 1, 2, 3 and 4 in the previous example we just used. Packet switching chooses the most shortest path possible for the data to reach the destination end. In case we have unreached packet or some unattained packet, the whole message from the sender side is sent again to the receiver end. Now let's look into some details regarding advantages and disadvantages of applying packet switching. Advantages of using packet switching is it provides rerouting in case the network node is busy. It also allows multiple users to access the same network and no predestined path is needed. The disadvantage of applying packet switching is the protocols that are needed for the working of packet switching is very complex. There are often cases of loss of data packets during the transmission in case of overloading or corruption of data. Now let's look into some information about the Go Back and ARQ protocol. This protocol applies the sliding window method for transmission of data in the network channel, where n in the protocol refers to the window size assigned in the network model. As for the term ARQ in the protocol refers to the automatic repeat request, which means the sender side will send multiple data frames to the receiver side according to the assigned window size. And only after it receives an acknowledgement from the receiver side will it continue to send the frames from the sender side. Moving on, let's look into some important points regarding the protocol. As to begin with, the method applied to share multiple frames from the sender side to the receiver side is known as the protocol pipelining, where each frame is assigned a sequence number for proper transmission of data in the network channel. Now let's move on to some other important points. As we already know, the n in the protocol refers to the window size, that is the maximum limit of frames that can be transmitted from the sender to the receiver side before reaching the acknowledgement for the previous frame. And in case if the transmission of the acknowledgement of a frame is not received within a certain time period, then all the frames from that sequence number are to be retransmitted in the channel. This point is to be remembered properly because this will be the key point in solving a question related to Go Back and ARQ protocol. Now let's move on to the working of the protocol. To begin with, we have a sender side and a receiver side, along with the sequence number, the window size for the network channel, and the number of frames will already be assigned in the network. Now, by applying the sliding window protocol, we will send the first 3 frames from the sequence continuously, which will be frame number 0, frame number 1 and 2. This is assigned according to the window size. After sending the frames, we will have a sliding window over the sequence numbers that are 0, 1 and 2. After the frames are sent to the receiver side, it will use the frames and send an acknowledgement signal to the sender side. That would be 0 for the first time. After which, we can share the next frame, that will be frame number 3, from the sender side to the receiver side. After sending frame 3, the sliding window from sequence number 0, 1 to 2 will shift over to 1, 2 and 3. And similarly, for frame number 1, we will receive the acknowledgement signal from the receiver side to the sender side. And then we can share the next frame, that is frame number 4, from the sender side to the receiver side. And the sliding window will shift over from sequence number 1, 2 and 3 to over 2, 3 and 4. As for the next frame, that is frame number 2, when we receive the acknowledgement from the receiver side, there is a catch. For any network issues, the acknowledgement is not received by the sender side. So in this case, as discussed earlier in one of the important points, the sender side will not transmit frame number 5. Instead, it will retransmit frame number 2, 3 and 4. Where the second frame is the one which did not receive the acknowledgement, and all the frames sent after second frame is to be retransmitted along with it, that is 3 and 4. What is parity bit check? The parity bit is a data check bit added to the original data for detecting errors at the receiver side by checking the integrity of the received data. The parity bit adds 1 or 0 to the original data that is to be transmitted to the receiver side, and if in case there is an error in the received data, the sender side will do the parity check and give the request for retransmission of the data. Now let's move on to the key points regarding parity bit check. To properly understand the working of parity bit check, we need to understand some key points, where the first one is redundant bits. They are the extra binary bits that are added explicitly to the original data to prevent the damage to the transmitted data or to detect the damage to the transmitted data. They are also used to recover the original data in case of a damage at the receiver end. The number of redundant bits added depends upon the type of check method used, regarding which, in this example, there are 4 data bits used, whereas 3 redundant bits. It can also be 2 redundant bits or 1 redundant bit. In case of parity check method, only 1 redundant bit is added to the original data. Now let's move on to the next key point, that is parity bits. The parity bit check method is a method to add binary bits to secure the original data. That is done by counting the total number of ones in the original data, which is either even or odd in number. The parity bit check method is used to detect error in the original data at the receiver side, and also in some cases it is used to correct the change. There are 2 types of parity bits available to choose from. The first one is odd parity bit. In this parity bit check, the number of ones in the original data, including the parity bit, should be odd in number. For example, in the given example, the number of green tiles has 4 ones, that is even. So the parity bit should be 1 in this case to make the total number of ones in the data 5, that is odd. Similarly, the other parity bit is known as even parity bit. In this case of parity type, the total number of ones counted is to be even, including the parity bit. For example, the number of ones in green tiles is 4, that is even. So the value of parity bit should be 0 in this case. The point to be noted is the parity bit value should always be correct because it acts as the error detection method at the receiver side. Now let's move on to the explained example to consolidate all the things we have learned so far. The question is, for the given data bit, that is 110111, apply the even parity bit check for data transmission. Now, let's begin. For the first step, let's take the original data, that is 110111, and the parity bit value is to be given as P. Now, according to the next step, we have to count the number of ones in the original data, which will come out to be 5 bits. That means there are 5 ones in the original data, which represents an odd number. To balance this according to even parity bit, now we have to add 1 in place of P. So the new data to be transmitted will become 110, 111 and 1, which will be transmitted to the receiver side by the sender side. After the data has reached the receiver side, there are a few cases that may arise in the data, where case 1 is the data bit received to transmission has no errors, that is, the data received is correct after applying the parity bit check, which in this case is even. So the transmitted data is this and the received data is this. That means both the transmitted data and received data are same. That means the received data is correct. Then the second case arises is the data bit received to transmission has errors. That is, the data received is damaged after applying the even parity check, which in this case the transmitted data is and the received data has an 0 instead of 1, which means the number of ones in this case becomes 5, which does not match with the even parity check, so it has an error. And the last case, case 3, in this the data bit received through transmission has errors, that is, the data received is correct according to the even parity bit, because the transmitted data has 6 ones, whereas the received data has 4 ones. But according to even parity check, only the number of ones should be even. That means the number of ones received by the receiver side is 4. So according to parity bit check, it is valid. But according to the original data, the received data is wrong. These are the 3 main cases that may arise during the transmission of data through parity check method.
In this interactive demo session on the top networking commands, we will look into some of the most popular commands applied by users to handle network issues and save precious time. So stay tuned. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. To begin practicing the commands, we need to access the command prompt application using the cmd command in the start menu. Now, let's begin with the list of commands. The first command is ipconfig. This command displays the system's basic IP address configuration data, which includes network information about IP addresses, subnet masks, and default gateway. Similarly, we also have ipconfig/all command, which displays all the details regarding our device, like LAN settings, physical address of the system, IP addresses, subnet masks, and DHCP information. Let's use the cls command to clear the application window for the next one. The next command is hostname, which is used to access the system's hostname. To verify this, let's use the ipconfig/all command to check the hostname in the information, and for sure, we have the same hostname. Let's perform the cls command again and perform the next command. The ping command is used to check the communication availability of the destination host and the user system. For example, use the ping command with google.com to check the server availability, which gives us the following result. Also, using the results IP address and then the ping command, we can get the same result in case we just don't have the domain name. We perform the cls command again and move on to the next one. The nslookup command is used to troubleshoot network connectivity and find the IP address of a domain like Google and Amazon as applied just now, to receive the name and address of the domain. Also, using the nslookup command and then applying the server command with an IP address, we can get the domain name belonging to the IP address. And similarly, to check the number of servers with the same domain name, we can do this, and we have 4 name servers for Google. We perform the cls command again and move on to the next one. The tracert command is used to troubleshoot the routing issues of the network by displaying the routing table through which the data is transmitted to a maximum of 30 hops in the network, as you can see. Similarly, you can also try amazon.com and share your views in the comment section below. Now, let's clear the application window and perform the next command, which is the ARP command. This command is applied to display the communication exchange between the IP address and the system's MAC or physical address. Let's move on to the next command, which is the path ping command. This combines the tracert and ping commands and displays detailed information as an output for a maximum of 30 hops in the network. This command takes some time to compile the full hop details so that you can share findings in the comment section. Next, we have the netstat command. It's used to display the network connection summary of the system as shown in the demo. Similarly, if we use the netstat-n command, it will give us much more details about the connection and UDP details. Next, we have the netshare command, which displays the details of where the data resources for our system are shared, and we can check them under the share name, resources, and remark column. Then we have the route command that allows us to access the routing tables and also allows us to make changes to them. Let's try the route print command, and we have the interface list, IPv4 routing table details with all the active routes and the IPv6 routing table. Moving on, let's clear the window and look at the netsh command. The netsh is a popular command which allows us to view and configure the network adapters in the system. Under the netsh command, we have multiple functions for configuring settings. Let's try the show command, and we have the following result. Moving on, we have the task list command that lists all the currently working applications on the system with task or program ID and the memory it uses. Let's perform an example. Access Google Chrome and then perform the task list command. And as expected, we have the Chrome details in the list. And if we close the Chrome window and again use the task list command, we don't have the application active. Similarly, we also have the task kill command, which will terminate the task corresponding to the given program ID in the command window. For example, let's access Chrome and perform the task list command to check the program ID. And then we'll use it with the task kill command, and we can see that the application is terminated. To check our result, we can access the task list command again. Next on the list, we have the system info command. It's used to view all the information about the system, from the Windows version to the BIOS and booting configuration. We can access all these details using the system info command. And the last network command for this session is the WMIC command. For getting detailed information on the ports and functions of the system like CPU details, and then similarly, we can check the BIOS settings.
If you are someone who is interested in building a career in cybersecurity or a networking professional by graduating from the best universities, or a professional who elicits to switch careers with networking by learning from the experts, then try giving a shot to Simplilearn's postgraduate program in cybersecurity with modules from MIT Schwarzman College of Engineering. The course link is mentioned in the description box below that will navigate you to the course page where you can find a complete overview of the program being offered.
Introduction to the algorithm. The Dijkstra's algorithm was invented by Edgar W. Dijkstra. This algorithm was designed to find the shortest path between the nodes of a communication channel. The Dijkstra's algorithm is also used to form a shortest path table for the given graph, and it works on the principle of greedy algorithm. Now let's move on to some key points regarding the algorithm. The first key point to be noted to solve a Dijkstra's algorithm is the algorithm is closely linked to position of the nodes in a graph. The next point is the attribute value between the nodes of a channel is used to deduce the shortest path. As for the last point we have, the initial value of all the nodes from the current node is assumed to be infinite. To much practically understand the functioning of the Dijkstra's algorithm, let's take a look at the principle for the same. The principle of the algorithm works as if the distance of u that represents the current node plus the length that is the attribute value between node u that is the current node and node v that is the target node is less than the attribute value to distance of the target node. And also the distance of the target node is equal to the distance of current node plus the length between target node and the current node, where distance u represents the source node or the current node and distance v represents the target node or the destination node. To much better understand, let's apply this. For the given question, let's find the shortest path. In this given example, we have three different nodes, node A, B and C. Using the previously discussed algorithm principle, we will deduce the shortest path for node A to the other nodes in the graph. That is, the shortest path from node A to node B and the shortest path from node A to node C. For this, let's take the node B first. According to the solution, it should be for node B on applying the algorithm along with the values we have if 0 that is the position of A is 0 plus the target node attribute value that is 10 is less than equal to infinite, that is initially as mentioned infinite value is to be assumed and this statement stands true, so the distance between node A to node B becomes 10. For the third step, we will look into distance between node A to node C. That would be 0 plus 40. That is the direct connection between node A to node C according to the example, which is less than infinity, again true. So the distance between node A to node C is 40. Moving on, but we have to find the shortest path. So for this, fourth step comes into picture. That is, for node C from node B on applying the algorithm we have 10, that is the initial value of node B, and plus 15, that is the attribute value between B and node C, which is 25 and is less than infinity. So the shortest path between node A to node C becomes 25 instead of 40, which was given through step 3. Using the same scenario and same steps, we will solve a much difficult question and understand how the algorithm is used. Then without further ado, let's move on to the solved example using the Dijkstra's algorithm. According to the given question, we have to use the Dijkstra's algorithm for the given graph and find the shortest path from node A to node C. The point to be noted is we need to find distance that is shortest between node A to node C only. Now let's take a look at the graph, and this is the given graph with node A at the current node and node C is to be the targeted node. But before we begin with the solution for the given graph, let's take a look at some of the important points to remember. The first point, the distance of node A from all the other nodes is infinite in the starting step, as discussed earlier in the example graph. The next point is, the node with the shortest value will become the next current node. Then we have this graph is done to maintain a proper shortest path value table, which will be very helpful during the solution of the graph. Now let's move on to the solution. To begin with, we will make shortest path table value that is given through this with 3 columns in it: node column, value column, and previous node. Now let's start with the actual solution. To begin with, the first step is to mark the current node, that is node A. Then the nodes that are directly connected to the current node, that is node B and node D. Now using the value distance, that is 3 for node A to node B and 8 for node A to node D, we will update our table, where the point to be noted is that we have updated the previous node as A for both the nodes B and D. Moving on, now let's choose the next current node, that is node B for the next case, because the shortest path in the given table is 3, which is less than 8. Now the directly connected nodes to node B are node D and node E. Similar to the case we did earlier, we will mark the shortest distance from node B to node D and node E. Let's deduce the distance. The distance between node B to node D is 3 plus 5, that is equal to 8. And then we have distance from node B to node D, that is 3 plus 6. So the value is 9. Now we will update our shortest path table, and the new table comes up to be from node D to node B we have 8, and node B to node E we have 9, with the previous node as B. Moving on, let's decide the next current node, that is D, because the shortest distance is 8 in comparison to 9 for node E. So the new current node is node D, and the directly connected nodes to node D is node E and node F. The point to be noted is the current node is chosen only from the unvisited nodes. Now for this we have distance between node D to node E is 8, that is the previous value we deduced, plus 3, that is the distance between node D to node E, and the total value comes up to be 11. Then we have to node F from node D, that is 8 plus 2, that is the distance between node D and node F. So the value becomes 10. On updating the shortest path graph table, we have the new distances, that is node F has 10 value with the previous node as D, and there is no change with the node D, because in comparison to 8, 11 is much bigger. Moving on, let's choose the next current node, that is node E, because in comparison to value 10 from node F, 9 is smaller. Now the node E is a current node, and the directly connected nodes are node F and node C. Now let's find the value between node C and node E. That will be 9 plus 9, that is the distance between node E and node C. So the value totals come up to be 18. And for node F and node E we have 9 plus 1, that is the distance between node E and node F. That comes up to be 10. Now let's compare with the graph table, where node F is originally at value 10, and again the value is 10, so there's no change. And C we have infinite, and the value 18 is much smaller, so the new graph would be something like this, with node C as 18 value and previous node as E. Now let's decide the next current node, that is node F, because the distance value is lowest in the given graph, that is 10, and for node C is 18. And the directly connected node is node C. Then the distance comes up to be 10 plus 3, that is 13. Using this 13th value, we can decide the current value of C is 18 and the new value is 13. In comparison, 13 is obviously less. So the new graphs comes out to be for node C value 13 and the previous node becomes F. With the completion of all the nodes in the given graph, we can reduce the shortest path from node A to node C. That comes up to be from node A to node D to node F, and node F to node C. And the total value comes up to be 13. With this, we have covered all the parts regarding the functioning and the working steps involved in the Dijkstra's algorithm. If you have any questions regarding the topic, you can ask them in the comment section. Introduction to distance vector routing. Distance vector routing refers to the distance or the vector that is between the neighboring nodes in a network channel, and the routing part refers to the established route through which data packets are transmitted in the network channel. The other aspect of this routing protocol in a network channel is to determine the shortest path for a data packet in the network to reach its destination. Next, we will look into some key points regarding the routing protocol. For routing protocol, three primary key points are to be remembered. First one being, each router in this protocol is designed to share the vector data of each node throughout the network. This step is done to maintain proper circulation of data in the network channel. The next key point is the routing pattern in the network protocol. That is, the data shared by the routers is transmitted only to those nodes that are directly linked to a particular router. The last key point is that the routing protocol is designed in a manner that it shares the updated vector data periodically at the network channel. Now let's move on to the next heading, that is the algorithm used in the protocol. The algorithm used in this protocol is termed as Bellman-Ford algorithm. This algorithm defines the shortest path that a data packet can take to reach its destination node from an initial node, where d of xy refers to the least distance from a node x to node y. Moving on, we have c of x comma v, where excess cost from each of its neighboring v node is taken into consideration. Then we have d of vy. This is the distance of each neighbor from its initial node. And lastly, min of v. This is an abbreviation we use to determine the most shortest vector after the solution is obtained using the algorithm. In the next heading, that is network example, we will understand all the points used in the algorithm. Now let's design a network model with 5 different nodes that are A, B, C and D, with each node connected to each other using different network channels. The numerical values in the network channel refers to the vector count, that is the distance from node A to node B or to some other node in the network channel. In a network model, each node shares its vector data with its neighboring node at a regular interval, as there are various updates in the network model. This data is shared in a form of routing table where three different columns are used. First being destination column, second vector column, that is the distance node, and lastly the hop. Let's take a look at the neighboring nodes for this model. For node A, we have B and E, as it is directly interlinked to the node A. For node B, we have node A and node C. For node C, we have B and D. For D, we have C and E. And lastly, for E, we have node A and node D. These nodes represent only the neighboring nodes. Now let's solve an actual example on routing protocol to clear all our doubts and understand the key points. The example we will be taking to solve is this network model. The initial step to start solving the network model using the distance vector routing protocol is to make routing table for each of the nodes. Let's make the routing table for node A. This is the routing table for node A, where we have destination as A. That means destination is A from node A. That means the distance vector should be 0. Then we have destination as B. Let's take a look. In this given example, there is no given connection between A and B. That means this distance vector would be infinity. Then we have destination as C. Similarly as node B, there is no direct connection between A and node C. That means this is also infinity. And same is the case with node D. And in the end, we have node E, that is the only directly linked node to node A. That means the distance given is 5. So the network vector is 5. Let's make another routing table for node E. This is the routing table for node E. Let's take a look. In this routing table, the first is destination to node A. According to the network model given, distance is 5. So the vector value is 5 with the hop to A. Then we have destination as node B. According to the model, the distance vector should be 4. Then we have destination as node C. As given, there is no direct connection between node E and node C. That determines the value would be infinity. Then we have node D, which represents direct connection with node E, and the value is 7. And lastly, E destination from initial point E would be 0 vector. Now let's make another routing table similarly for node C. Now using the same steps, you can make the routing table for the remaining nodes, that is node B and node D. Now let's move on to the next step in solving the routing issue. This step is known as update step. In this step, we use the vector column from each of the node to update the vector column or the routing table for a particular node. In this part, we'll use node E's vector column to update the routing table for node A. And the steps are using the algorithm, that is the Bellman-Ford algorithm we used earlier. As we already know, moving from A to destination node A is always 0. So we won't be doing this step. Let's move on to the next one, that is moving from node A to node B. That would be A comma E, as we are using vector column of node E plus and the distance used to reach E from B. A comma E represents 5 and E to B represents 4 according to the network model. So the value is 9. Similarly, let's solve for A to C. To A to C we have A comma E plus destination required to move from E to C. According to the network model we have, node A is only directly linked with node E, so the value would be 5. But there is no connection between node E and node C, so the value would be infinity. Moving on, we have A to D. In this case, we have A comma E. The value would be 5 plus E to D, that is a direct connection, and the value would be 7. So the total distance is 12. And the last one is A to E. For this we have A comma E, that is directly the neighboring node. The value would be 5. So the new routing table for node A is 0, 9, infinity, 12 and 5. Similarly, let's take another node for this. For the next node, we will take node C and we will update the routing table of node C using its neighboring nodes, that are node B and node D according to the network model. Now, how to do this step? Firstly, it's C to destination A. In case of node B, we have C to A, that would be C comma B, that is a direct connection, plus distance required from B to A. According to the network model, we have C comma B as 6, plus B to A does not have any connection, that is infinity, so the value would be null. Then we have node D. In this case, we have C comma D, that is a direct connection, 3 plus D to A, that is again infinity, as it is not linked directly to node A. Moving on, we have destination as B. For node B, we have direct connection, so C comma B value is 6. Whereas for node D, we have C comma D, that is distance 3, plus D to B, that is infinity, as it is not directly linked with the node B. So again the value is null. Then we have destination as C. So connection between C to C is 0. Moving on, we have destination at node D. That would be C to D, as C to D, as there is no direct connection between node B and node D. So the value is infinity. Whereas for C to D is a direct connection for node D. So the value would be 3. Now for the last node, that is node E. In case of node B, we have C comma B plus B to E, where the value for C to B node is 6 and B to E is 4. So the sum is 10. And now in case of node D, we have 3 plus 7. That would be distance from C to D and then D to E. And the value would be again 10. So we can use any of the side to reach the destination node E. By completing all the steps, we have the new table for node C. Similarly, we can find the routing table for all the nodes present. Now, to look into some key points we learned. For the initial step, use only the node distance of immediate neighbors. Nodes without distance that is directly linked to each other is always infinity. For the update step, use the vector table of the only neighboring node we have for the initial node. And lastly, to continue the update step, roughly n-1 iterations are used, where the value of n is equal to the number of nodes. For example, the model we took had 5 nodes. That means we have to do a loop of 4 iterations. What is HDLC? Let's take a look. The HDLC stands for High Level Data Link Control. Refers to the bit-oriented network protocol designed to connect multiple network systems according to the communication requirement. The HDLC model applies the ARQ protocol for application and establishes a full duplex communication channel between the network devices. Moving on, we have the different types of HDLC stations available. HDLC stations can efficiently be differentiated into 3 different types, where the first type is primary station. In this station, it handles the establishing and destablishing of the primary data channel to share different frames in the network channel, known as commands. It also performs the data management for the network. Moving on, we have the secondary station. This station works under the command of the primary station, and the frames issued by the stations are known as responses. As for the last station, we have combined station. As the name suggests, this type of station is available for both commands and response value. Next, we will look into HDLC transfer models. The HDLC protocol supports 2 types of transfer models, which are applied according to the need of communication channel, where the first type is known as normal response model, or in short, NRM. This transfer model combines the primary station and the secondary station in a point-to-point or multi-point configuration to exchange commands from primary station and responses from the secondary station, and response to the multi-connection. Moving on, we have the second type of transfer model, which is asynchronous balanced model. In this transfer model, the combined stations are installed in a point-to-point configuration for exchange of command or responses from either of the node. Moving on, let's take a look at the HDLC frame model and types. The data unit for sharing information in the HDLC protocol is known as frames. The HDLC frame consists of multiple frame fields which may vary according to the frame type. In general, the HDLC frame consists of 5 different frame fields, where the first field is flag field. In HDLC, each frame starts with the flag field in the configuration and is defined by an 8-bit octet sequence, which is 0, 1, 1, 1, 1, 1, 0 in the flag field. Moving on, we have the address field. It encapsulates the receiver's address in the field. For example, if the frame is sent from the primary station, it contains the secondary station's address and vice versa. Next, we have the control field. This field contains the flow and error control information in byte format. Next, we have payload or the information field. It carries the actual information from the upper layer of the OSI model. And the last field is known as FCS field. This field stands for Frame Sequence Check and acts as an error detection field in the HDLC protocol, which includes a 6-bit CRC check. Given is the frame format for an HDLC protocol, with flag in the both ending and the starting point, followed by address field, control field, information field, and FCS field. Now let's take up a quiz to understand all the things we have learned so far. The question is, the HDLC protocol functions under which network layer in the OSI model? And the options are application layer, data link layer, physical layer, and the network layer. You can give your answers in the comment section. Now let's move on to different types of frame models available in HDLC. The frame models in HDLC can be classified of following three types depending upon the control field value of the frame, where the first frame is known as I frame. The I frame stands for information frame and is applied to encapsulate the user information from the upper layer in the model and then transmit it to the network channel. Note, the first bit of the control field in this frame is always 0, which also acts as an identification point for I frame. Moving on, we have the S frame. The S frame stands for supervisory frame and is used for error and data flow control and does not contain any information regarding the information field in the format. Note for the S frame is the first two bits of the control field is 1 and 0, which acts as an identification point for S frame. As for the last type of frame model, we have U frame. The U frame stands for unnumbered frame, used for system management and exchanging information between connected network devices. With this, we have covered all the relevant information regarding the HDLC protocol. The checksum is one of the most applied error detection method in the network channel and is a bit-based format detection method. The checksum uses checksum generator on the sender side to perform the checksum method and the checksum checker on the receiver side to check whether there is an error in the data or not. Let's continue with the next heading, that is why to apply checksum method. Using the checksum method at the sender side, the checksum value is added to the original data to be transferred as an error detection method, whereas at the receiver side, it decodes the incoming data from the sender side according to the checksum method to detect any changes in the given data. Now let's move on to the working steps involved in the checksum method. There are various steps involved in the checksum method. Let's take a look at the first step. That is, the first step begins at the sender side, where we divide the original data into k parts of n bits, continuing with adding all the k blocks we have obtained. Then the addition result is complemented using one's complement. The data now obtained is known as the checksum value. Next, let's look at the step 2. Data transmission. After we have received the checksum value from the checksum method, we will add it to the front of the original data and transfer it to the network channel to the receiver side. Now, step 3. Step 3 begins at the receiver side. That is, it will divide, that is, the receiver side will divide the obtained original data plus the checksum value into k blocks and then add all the k blocks using addition. After that, we will complement the obtained data. If the complement of 1 comes out to be 0, that is, no errors are received in the data and the receiver will accept the data. Whereas for case 2, if the result is not 0, the received data is damaged. So the receiver will discard this data and request for retransmission of data from the sender side. Now, after understanding all the points regarding working of the checksum method, let's take a look at a solved example to better understand all the points. The question is, for the given data, perform the checksum method. This is how we divided all the 4 parts. Each of these represents a k block, that is 4 blocks, and 8 bits in each of the block, that is n bits. Now for the first step, that is at the sender side, we will add all the given data. So the value would come out to be 1000, that would be 1, 0100 would be 1, 0011 would be 1 carry 0, so 1 carry plus 1 means 0 plus 1 carry again, 1 carry plus 1 means 0 and 1 carry again, 1 0 1, that is 1 carry 0 plus 1 plus 0 means 1. So 1 carry is over on this side. 1 plus 0 is 1, 1 plus 1 is 1 carry 0, 0 plus 0 is 0, 0 plus 0 is 0 and 0. And we have 1 carry over here. So the obtained data would be 1 0 with extra bit as this. Now to resolve this issue, we will now add the extra carry to the obtained data from the addition part. That would be 1 0 1 0 0 1 0 0. Now at the sender side, we will do 1's complement for the obtained addition value. That would come out to be 110 11010. That is the checksum value. Now this value addition to the original data will be shared to the receiver side, where at the receiver side we will again perform the addition method, and the value comes out to be this, along with 2 digits of extra bit, that is the carry. Again, similarly, we will add this carry to the addition value and get the new data, that is all ones. Now again, going by the steps, we have to perform 1's complement for this value obtained. That comes out to be all zeros. That means the checksum value is 0 at the receiver side, which indicates that there are no errors in the received data by the receiver side. With this, we have completed all the points regarding working of the checksum method. Now, to better understand all the steps, let's take up a quiz. That is, for the given data, find the checksum value, where the given options can be one of them. You can give your answers in the comment section. What is parity bit check? The parity bit is a data check bit added to the original data for detecting errors at the receiver side by checking the integrity of the received data. The parity bit adds 1 or 0 to the original data that is to be transmitted to the receiver side, and if in case there is an error in the received data, the sender side will do the parity check and give the request for retransmission of the data. Now let's move on to the key points regarding parity bit check. To properly understand the working of parity bit check, we need to understand some key points, where the first one is redundant bits. They are the extra binary bits that are added explicitly to the original data to prevent the damage to the transmitted data or to detect the damage to the transmitted data. They are also used to recover the original data in case of a damage at the receiver end. The number of redundant bits added depends upon the type of check method used, regarding which, in this example, there are 4 data bits used, whereas 3 redundant bits. It can also be 2 redundant bits or 1 redundant bit. In case of parity check method, only 1 redundant bit is added to the original data. Now let's move on to the next key point, that is parity bits. The parity bit check method is a method to add binary bits to secure the original data. That is done by counting the total number of ones in the original data, which is either even or odd in number. The parity bit check method is used to detect error in the original data at the receiver side, and also in some cases it is used to correct the change. There are 2 types of parity bits available to choose from. The first one is odd parity bit. In this parity bit check, the number of ones in the original data, including the parity bit, should be odd in number. For example, in the given example, the number of green tiles has 4 ones, that is even. So the parity bit should be 1 in this case to make the total number of ones in the data 5, that is odd. Similarly, the other parity bit is known as even parity bit. In this case of parity type, the total number of ones counted is to be even, including the parity bit. For example, The number of ones in green tiles is 4, that is even. So the value of parity bit should be 0 in this case. The point to be noted is the parity bit value should always be correct because it acts as the error detection method at the receiver side. Now let's move on to the explained example to consolidate all the things we have learned so far. The question is, for the given data bit, that is 110111, apply the even parity bit check for data transmission. Now let's begin. For the first step, let's take the original data, that is 110111, and the parity bit value is to be given as P. Now according to the next step, we have to count the number of ones in the original data, which will come out to be 5 bits. That means there are 5 ones in the original data, which represents an odd number. To balance this according to even parity bit, now we have to add 1 in place of P. So the new data to be transmitted will become 110, 111 and 1, which will be transmitted to the receiver side by the sender side. After the data has reached the receiver side, there are a few cases that may arise in the data, where case 1 is the data bit received to transmission has no errors, that is, the data received is correct after applying the parity bit check, which in this case is even. So the transmitted data is this and the received data is this. That means both the transmitted data and received data are same. That means the received data is correct. Then the second case arises is the data bit received to transmission has errors. That is, the data received is damaged after applying the even parity check, which in this case the transmitted data is and the received data has an 0 instead of 1, which means the number of ones in this case becomes 5, which does not match with the even parity check, so it has an error. And the last case, case 3, in this the data bit received through transmission has errors, that is, the data received is correct according to the even parity bit, because the transmitted data has 6 ones, whereas the received data has 4 ones. But according to even parity check, only the number of ones should be even. That means the number of ones received by the receiver side is 4. So according to parity bit check, it is valid. But according to the original data, the received data is wrong. These are the 3 main cases that may arise during the transmission of data through parity check method. The Hamming code method is a network technique that is designed to detect errors and corrects data bits which are transmitted during data exchange. It was first implemented by R.W. Hamming, hence the name Hamming code. This network technique is implemented because during data transmission, there are often cases where data loss or data damage occurs. To recover or detect the damage in the original data, we use Hamming code. In the next slide, we will look into some terms that are related to the working of Hamming code. The first one being redundant bits. These are the extra binary bits that are added explicitly to the original data bit to prevent damage to the transmitted data and also to recover the original data in case of a damage at the receiver end. In the next point, we will look into some formula related to redundant bits and how to add them in the Hamming code. The formula related to redundant bits is 2r more than equal to m plus r plus 1, where m refers to the data bits in the data and r refers to the redundant bits. Let's take an example. In case m is equal to 4, that means the data bits used are 4, we need to find the value of r. Using the above formula, let's deduce the value of redundant bits. 2r is more than equal to 4 plus r plus 1. 2 to the power r is more than equal to r plus 5. So using this, let's use r equal to 0. If we use that, we will get a value 1 that is more than equal to r plus 5, but that is wrong. Then using r equal to 3, that is 8 is more than equal to 8. This way, we conclude that the Hamming code would be 7-bit data because the value of r is 3 and m is 4. Now let's move on to the next term related to Hamming code, that is parity bits. The parity bit is a method to append binary bits to secure that the total number of counts of 1 in the original data is either an even number or an odd number. Let's take a look why do we exactly use parity bits. They are used to detect error in the original data which occurs during the transmission of data. Through this method, we can detect the error at the receiver end and also correct it. Let's take a look at different types of parity bits available. First one is even parity bit. In this case of parity type, the total number of ones counted is to be even in the count. In case the count is odd, then the value of parity is 1. Otherwise, the value should be 0. Similarly, the other parity bit is known as odd parity bit. For this parity bit, the total number of ones counted in the original data should be odd. If that is the case, the value of parity bit should be 0. And in case the value of ones in the original data comes out to be odd, then the parity value would be 1. Now let's move on to the next setting, that is the working example of the Hamming code. Let's take a look. Let's begin with the steps to be followed to solve a Hamming code issue. The first point being the position of the parity bit is determined using 2 to the power n term, where n represents the number series 0 to n. Assigning the position for parity bit using this method would be more clear during an example. For the second point, we have the remaining positions represents the data bit. Now let's try using the value of parity bit for n is equal to 0. That means 2 to the power 0 is equal to 1. So all the bits with 1 in the last position are used to determine the value of the parity bit. To better understand the assignment value of parity bit, please focus on this mentioned table. In this table, we can take a look at the last position, that is n is equal to 0, and see the mentioned number. For P1, we can use a value 1 because n is equal to 0 and the last position value is 1. Then is number 3 because the last position bit is 1. Then similarly for number 5 because n is equal to 0 and the bit value is 1. So these three parity value can be used for n is equal to 0. Similarly, let's take a look when the n is equal to 1. That means 2 to the power 1 is equal to 2. So all the bits with 1 in the second position are used to determine the value of parity bit. Now let's take a look at the table to identify the numbers related to this parity bit value. The first one being 2 due to the presence of 1 bit in the second position. Then we have P3, presence of 1 bit in the second position. Similarly, the next would be number 6 due to the presence of 1 bit in the second position. Similarly, let's take a look at when n is equal to 2. That means 2 to the power 2 is equal to 4. So all the bits with 1 in the third position are used to determine the value of parity bit. And this would be 4, 5 and 6 number. Please read the points very carefully because next we will solve an example to better clarify all the concepts. Let's move on. The given example is the data bit to be transmitted is 1011 and we have to solve this using the Hamming code method. So the first step would be applying the Hamming code method and identify the given number of data bits. That would be 4 according to the question. So the number of parity bit would be 3, where the value would be 1, 2 and 4 according to the power of P expression. That means we will get something similar to this. This representation is in data bit format, where the first position is for P1 parity bit, the second for 2 to the power 1, that is 2 P2, and the third one is for 2 to the power 4, that is P4 parity. And let's put the value that is to be transmitted in the remaining positions. That would be P1, P2, 1, P4, 1, 0 and 1. Using this bit value, we will deduce the value of P1, P2 and P4 for data transmission. In this case, we are using even parity for the example. That means the number of ones should be even. Let's take a look. For P1 we have D1, D3, D5 and D7 as mentioned in the earlier slide. So the value would be P1, 1, 1 and 1 according to the data bits available to us by the question. That means the value would be 1 because the number of ones for P1 is odd. So to make it even, the value of P1 would be 1. Similarly, for P2 we have D2, D3, D6 and D7. Using the same method, we will get P2, 1, 0, 1. So the number of ones for P2 is even. So the P2 value would be 0. Next is for P4. The value is D4, D5, D6 and D7, where P4 has 1, 0 and 1. That means the number of ones is even. So again P4 is equal to 0. Now using this, we get the new bit that is to be transmitted. That is 1010101. After transmission, in case, let's say at position 5 an error occurs and the value of 1 is converted to 0. To detect this error at the receiver side, we will use the Hamming code. To begin with, we will use the parity value to cross-check the original data bit. That means, let's do the parity bit method for this received data. So for P1 we have D1, D3, D5 and D7. So the number of ones is odd. That means the value of P1 should be 1 to make it even. Then for P2 we have D2, D3, D6 and D7. So the number of ones is even. That means the P2 value would be 0. Now let's move on for P4. That would be 4, D5, D6 and D7. Number of ones is 1. That means odd. So the value of P4 would be 1. Now let's take a look at the results that we obtained using this method. Foremost, this shows that the data transmitted is damaged and we can detect the error position using this method, that is, using the value of parity bits obtained, where this will lead to 2 to the power expression. That means 2 to the power 0 plus 0 plus 2 to the power 2. That means 5. That matches with the assumption we took. Now, to correct this error, we can use the position that we obtained, that is 5, and replace the 0th value with 1 bit. By doing this, we will obtain the original data. Now let's move on to the first heading, that is Introduction to the Protocol. The stop and wait protocol is a type of flow control mechanism active in the OSI model of the data link layer. The transmission of data applies only to the noiseless channels, where a noiseless channel represents an ideal network channel where no frames are lost, duplicated, or hacked. Moving on, we have the stop and wait protocol is unidirectional in transmission of data, that is, either sending or receiving data will only take place at an instance. For the third point we have, the stop and wait protocol, as the name suggests, is when the sender shares a data packet to the receiver end. Then the sender side has to stop and wait for the receiver side to send an acknowledgement before it starts sending the next data packet. With this point, we are now knowledgeable about the working of the stop and wait protocol at an elementary level. Now let's move on to the next heading. The next heading for the session is Steps involved in the stop and wait protocol. The steps for this protocol are divided into two parts, sender and receiver protocol. Let's start with the sender side. The first step is to transmit one data unit at a time to the receiver end by the sender side. And the next step is to transmit the next data until only after we receive the acknowledgement from the receiver end. Now let's move on to the receiver side. In receiver side, step 1 is to receive the data and use the data that is being sent. Then the second step is, after the data has been used by the receiver side, it will send the acknowledgement to the sender side for further data transmission. This is how the transmission of data takes place in the data protocol. Now let's move on to the next heading, that is working of stop and wait protocol. Using the previous two headings, we can easily determine the steps involved in this working. Let's take a look. To begin with, we have two sides, the sender and the receiver side. The first step is to send the data from the sender side to the receiver end. And after the receiver side has used the data, it will send the acknowledgement signal. Meanwhile, the sender side has to wait for the acknowledgement signal. Only after it receives the acknowledgement signal will it send the next data packet. Now that the sender side has sent the data for the second time, the receiver side will use this data and then only share the acknowledgement signal. This process of sending data from the sender side to the receiver side and receiving acknowledgement from the receiver side to the sender side continues for n number of times according to the given scenario in the network channel. Now let's move on to the next heading, that is also the last heading for this session, that is drawbacks of using stop and wait protocol. The first drawback of using this protocol is the loss of data. This issue can arise when transmitting data from the sender side to the receiver end. It may be due to any issue, due to hacking attempt or network disruption or any other network related issue. Then, this can also arise when receiving acknowledgement from the receiver side. Now let's move on to the second drawback. The next issue is related to acknowledgement transmission, that is, during the transmission of acknowledgement signal, due to the network issues, the acknowledgement signal is disrupted and the transmission is terminated. This can arise again due to any reasons that are occurring in the network channel. Now let's move on to the last drawback for this heading. The last issue occurs due to the delay in transmission time of the information. Time delay drawback can occur on either side of the transmission, that is, during data transmission or the acknowledgement transmission. As we know, in a networking concept, protocols refers to the rules and instructions that governs the data transmission between different network models and devices in a communication channel. The data transmitted using protocols is easily handled and is reliable to use, as well as it provides a secure channel for the data to be transmitted. Now let's move on to the different types of protocols available in a network channel. The protocols available in a network channel can be divided into two different types: noiseless channels and noisy channels, where the noise part refers to any external interference, data error, or duplicate transmission in the network channel. Furthermore, noiseless channels and noisy channels can be divided into subdivisions. Let's take a look at the noiseless channels first. Noiseless channels can be divided into two types: simplest type and stop and wait type, whereas noisy channels are divided into three subdivisions: stop and wait ARQ, go back and ARQ, selective repeat ARQ. In the noisy channel, go back and ARQ and selective repeat ARQ are the ones that apply the sliding window protocol for data transmission over the network channel. Now let's look into some information regarding sliding window protocol. To begin with, the sliding window protocol is a technique that allows the share of multiple data frames in a network channel, where the number of frames shared is determined by the window size assigned to the network channel. Also, the frames sent during transmission are assigned with a sequence number for efficient frame transmission in the communication channel. Till this point in the video, we have already learned about the definition of what is the sliding window protocol. Now let's look into the working steps of the sliding window protocol. To begin with, we have a sender side and a receiver side in the network channel. Then we require the frames, where each frame is given a sequence number. For this example, we are using 0 to 8, which means a total of 9 frames are available at the sender side. Then using the window size, we determine the number of frames that can be shared at an instance. For example, we'll be using 3 as the window size for this example. Let's start with sending the first frame, that is 0, to the receiver side. After the frame is sent, a sliding window appears on the number of frames. Now let's move on to the next, that is frame 1. The point to be noted is, before receiving any acknowledgement, we have to send all the frames that are available according to the window size. That is, for this example, the window size is 3. That means we have to send 3 frames before we receive any acknowledgement from the receiver side. Let's send the last frame, that is frame 2. Now we have to wait for the receiver side to send the acknowledgement signal to the sender side before we can send the next frame. Now that we have shared the maximum number of frames, the receiver end will share the acknowledgement signal for frame 0 with the sender side. After this acknowledgement is received by the sender side, we can share the next frame in the list, that is frame 3. After the frame 3 has been sent, see the positioning of the sliding window. The sliding window now changes from 0, 1, 2 to 1, 2 and 3 frame. This positioning of the sliding window represents that 0th frame has already been acknowledged by the receiver side, whereas the 3rd frame is sent for acknowledgement from the receiver side by the sender side. And similarly, we have to do the same pattern for the next 2 frames, that is frame number 1 and frame number 2. Now the sender side will receive the acknowledgement for frame 1 from the receiver side, and we can send frame 4 from the sender side to the receiver side. Now see the movement of the sliding window. The sliding window changes from 1, 2 and 3 frame number to 2, 3 and 4. Similarly, we can move on to the last frame. Now let's draw some simple conclusion from all the working steps we have seen so far. To begin with, frame number 1 and 0 represents the acknowledged frames, whereas the frames within the sliding window represents the frames that are waiting acknowledgement, whereas the remaining frames 5, 6, 7 and 8 are not yet shared with the receiver side. Now let's move on to the next heading for the session. Difference between stop and wait protocol and sliding window protocol. The first comparison is on the basis of working mechanism, where the stop and wait protocol is designed to send the data frame at a single time and wait for the receiver to send the acknowledgement to share the next frame. As for the sliding window protocol, sender can send multiple frames simultaneously and then wait for the corresponding acknowledgement from the receiver end. Let's move on to the next comparison, that is based on the window size. On the basis of window size, the stop and wait protocol is always fixed at 1. As for sliding window protocol, as we saw in earlier slides, it varies according to the scenario in the network channel. Let's take a look at some other comparisons too. The next comparison is based on efficiency and time delay. As comparison on this basis, the stop and wait protocol is efficiently low and suffers from more time delay. As for sliding window protocol, the efficiency is higher than the stop and wait protocol, which provides lower time delay during data transmission. Let's move on to the last comparison. Sorting and transmission of data. For stop and wait protocol, sorting is not required and it applies half duplex system for data transmission. As for sliding window protocol, we require sorting for better efficiency and is full duplex in nature. With this, we have reached the end of the video. Now let's look into some information about the go back and ARQ protocol. This protocol applies the sliding window method for transmission of data in the network channel, where n in the protocol refers to the window size assigned in the network model. As for the term ARQ in the protocol refers to the automatic repeat request, which means the sender side will send multiple data frames to the receiver side according to the assigned window size. And only after it receives an acknowledgement from the receiver side will it continue to send the frames from the sender side. Moving on, let's look into some important points regarding the protocol. As to begin with, the method applied to share multiple frames from the sender side to the receiver side is known as the protocol pipelining, where each frame is assigned a sequence number for proper transmission of data in the network channel. Now let's move on to some other important points. As we already know, the n in the protocol refers to the window size, that is the maximum limit of frames that can be transmitted from the sender to the receiver side before reaching the acknowledgement for the previous frame. And in case if the transmission of the acknowledgement of a frame is not received within a certain time period, then all the frames from that sequence number are to be retransmitted in the channel. This point is to be remembered properly because this will be the key point in solving a question related to go back in ARQ protocol. Now let's move on to the working of the protocol. To begin with, we have a sender side and a receiver side, along with the sequence number, the window size for the network channel, and the number of frames will already be assigned in the network. Now, by applying the sliding window protocol, we will send the first 3 frames from the sequence continuously, which will be frame number 0, frame number 1 and 2. This is assigned according to the window size. After sending the frames we will have a sliding window over the sequence numbers that are 0, 1 and 2. After the frames are sent to the receiver side, it will use the frames and send an acknowledgement signal to the sender side. That would be 0 for the first time. After which, we can share the next frame, that will be frame number 3, from the sender side to the receiver side. After sending frame 3, the sliding window from sequence number 0, 1 to 2 will shift over to 1, 2 and 3. And similarly, for frame number 1, we will receive the acknowledgement signal from the receiver side to the sender side. And then we can share the next frame, that is frame number 4, from the sender side to the receiver side. And the sliding window will shift over from sequence number 1, 2 and 3 to over 2, 3 and 4. As for the next frame, that is frame number 2, when we receive the acknowledgement from the receiver side, there is a catch. For any network issues, the acknowledgement is not received by the sender side. So in this case, as discussed earlier in one of the important points, the sender side will not transmit frame number 5. Instead, it will retransmit frame number 2, 3 and 4. Where the second frame is the one which did not receive the acknowledgement, and all the frames sent after second frame is to be retransmitted along with it, that is 3 and 4. To much better understand the solution for the example we will be solving later in the video, it is suggested that you watch the steps involved in the working of the Go Back and ARQ protocol again. Now moving forward, let's take a look at some of the advantages and disadvantages of using the protocol in a network channel. For advantages we have, it increases the efficiency of transmission of frames. It also allows multiple frames to be sent at once. And the time delay is low for sharing the packets. As for disadvantages we have, the retransmission of frames in case of an error in the network channel is a very difficult work. And it also requires the storing of frames on the receiver side that it receives from the sender side. Now that we have learned everything about the Go Back and ARQ protocol, let's take a look at the much awaited working example for the same. Let's take a look at the problem statement. In a given network, the number of frames provided is 10, with the window size assigned as 3, and for every fourth packet is lost. Find the total number of messages or frames sent from the sender side to the receiver side. From this question, we can get three main parts, that are the number of frames that are given is 10. As for the window size is 3, and every fourth packet is lost. Let's take a look at the options. Option A 27, option B 25, option C 22, and option D 29. I'll give you guys a moment to take a look at the question again. Now let's move on to the solution. As usual, we have the sender side and a receiver side. And according to the question, we have 10 frames. Numbering the frames sequentially, we have frame 1 to frame 10. And then according to the question, we have window size as 3. Now, using the sliding window method, we'll send the first 3 frames, that is frame number 1, 2 and 3, from the sender side to the receiver side. That will be like this. After sending the frames, we'll wait for the receiver side to send the acknowledgement, and a sliding window will appear on frame number 1, 2 and 3. Now the receiver side will send the acknowledgement for frame 1 to the sender side. And using this, we can send frame number 4 from the sender side to the receiver side. And a sliding window appear on 2, 3 and 4 sequence number. And similarly for frame number 2, we'll send the acknowledgement from receiver side to the sender side. And send frame number 5 from sender to the receiver side. And a sliding window appears on sequence number 3, 4 and 5. Then again, for frame number 3, we'll send the acknowledgement from the receiver side to the sender side. And send frame number 6 from the sender to the receiver side. And a sliding window appear on frame number 4, 5 and 6. Now let's move on for the next frame for acknowledgement, that is frame number 4. For this frame, according to the given question, every fourth frame is lost during transmission from the sender side to the receiver side. That means no acknowledgement will be sent from the receiver side to the sender side for frame number 4 in that regards, or any other frame that are sent after frame number 4, that is frame number 5 and frame number 6. Similarly, frame number 5 and frame number 6 will also get discarded. Now, let's retransmit according to the go back NARQ protocol. Frame number 4, frame number 5 and frame number 6. After retransmission, frame number 4 will get acknowledged by the receiver side to the sender side. That means we can send next frame, that is frame number 7 from the sequence order. And the sliding window appears on frame number 5, 6 and 7. Similarly, let's move on to frame number 5. But before we do that, let's count the position of 5th frame in the transmission order. 1, 2, 3, 4, 5, 6, 7 and 8. That's correct. When we count the position number for any of the frames from the beginning, we use sequence, not the sequence number given by the question. That means 5th frame is at the position number 8 from the beginning. That means according to the question, it will get lost during the transmission from sender to the receiver side. Similarly, frame number 6 and frame number 7 that was sent after 5th frame will also get discarded. According to the go back NARQ protocol again, we will retransmit 5, 6 and 7 frame number to receiver side from the sender side. After retransmission, frame number 5 will get acknowledged by the receiver side, and then we can share frame number 8 from the sender to the receiver side, and the positioning of the sliding window shift from 5, 6, 7 frame to 6, 7 and 8 sequence number. Now let's move on to the 6th frame. But according to the positioning order, position of the 6th transmitted frame is number 12. That means it will get lost during transmission from sender to the receiver side. And similarly, frame number 7 and 8 will also get discarded by the receiver side. And again, applying go back NARQ protocol, we will retransmit frame number 6, 7 and 8. On retransmission, frame number 6 will get acknowledged by the receiver side, and we can share frame number 9 from the sender to the receiver side. And the sliding window will shift from sequence number 6, 7 and 8 to 7, 8 and 9. Now let's recount the position of the next frame, that is frame number 7 from the beginning, and that would be 16. That means frame number 7 will get lost during transmission from the sender to the receiver side. And similarly, frame number 7, 8 and 9 is to be retransmitted. according to the go back and ARQ protocol. Now similarly, following all the previous steps, we can complete this network model using go back and ARQ protocol. But this is a work you guys have to complete and find out the total number of packets that were transmitted from the sender to the receiver side, and give your answers in the comment section. And the next heading is, what is selective repeat ARQ protocol? For the first point in selective repeat ARQ protocol we have is the working principle. The working principle of the SRP protocol is based on sliding window protocol, and it uses a buffer system for storing either at the sender side or the receiver side during the data transmission. Let's move on to the next point for selective repeat ARQ. The term ARQ in the protocol defines the automatic repeat request process that is designed to perform the task of sending the next frame for each of the acknowledged frame. Now, let's move on to the next heading. Next heading is important points about the protocol. For the first point we have is the value of n that represents the window size is same for both sides. That is, the value of sender size is equal to the window size of the receiver side. Let's take a look at the next point. In case of selective repeat ARQ protocol, as the name suggests, in case the frame is not received by the receiver side or the acknowledge is not received by the sender side, as shown in the diagram. In this case, the mentioned frame is to be retransmitted without affecting any other frame. Let's move on to the next point for this heading. In case the frame is not received by the receiver side, then it will share a negative acknowledgement signal to the sender side so that it can retransmit the damaged frame. This point forms the basis of the working process involved in the SRP protocol. So please take a note of this point. Now let's move forward with the working of the protocol. We'll divide the working process of the SRP protocol in multiple steps for better understanding. Let's move on for the first step. To begin with, we have a sender side and the receiver side as usual. Then we have a sequence of numbers and a window size. Now, for the second step, let's send the first data frame, that is frame 0. Next is frame 1, frame 2, and frame 3. These 4 frames are sent for the beginning because our window size is 4. And a sliding window appears from sequence number 0 to sequence number 3. After the receiver side have received the sender side's frames, it will acknowledge the first frame, that is frame 0, and send the acknowledgement signal to the sender side. After the sender side receives the first acknowledgement signal, it will again share the next frame in the sequence, that is frame number 4. And the sliding window will shift from frame 0 to 3 to 1 to 4. Now similarly, let's acknowledge frame number 1 from the receiver side to the sender side. And the sender side will share the next frame in the sequence, that is frame number 5 to the receiver side. And the sliding window will shift from frame 1 to 4 to sequence number 2 to 5. Now, let's acknowledge frame number 2. Okay, now let's assume that frame number 2 is lost or corrupted during the transmission. In this case, if we apply go back and ARQ protocol, all the frames sent after frame number 2 are to be retransmitted. That will be frame number 2, 3, 4 and 5. But in case of SRP protocol, that is Selective Repeat Argue Protocol, only the frame that is lost during transmission is to be retransmitted. That means the acknowledgement signal for frame number 3 will be sent from the receiver side to the sender side, and the sender side will then retransmit frame number 2 to the receiver side. This process of retransmitting only the lost frame is known as the Selective Repeat ARQ protocol. And similarly, we will acknowledge the next frame, that is frame number 4, and send the next frame, that will be frame number 6. As you can see, in this process of SRP protocol, the sliding window or the window size clearly does not play any particular role. With the completion of this slide, we are done with the whole working steps involved in the SRP protocol. Now let's move on to the next heading in the video.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
The next heading in this session is difference between Selective Repeat ARQ protocol and Go Back N ARQ protocol. Let's take a look. For the first point, we have in Go Back N ARQ protocol, it does not require a large amount of memory as it does not provide the buffer feature for the network model. Whereas in case of Selective Repeat ARQ protocol, it requires a buffer system, so the memory needed is more on both the sides, that is the sender side and the receiver side. Now let's move on to the next point. All the frames after the lost frame in Go Back N ARQ protocol are to be retransmitted, as we already discussed in the earlier slide. Whereas in case of Selective Repeat ARQ protocol, only the damaged or the lost frame is to be retransmitted. Let's take a look at some other points too. In Go Back N ARQ protocol, too many retransmission frames are required, so the efficiency of the overall model is very low. And in case of SRP protocol, the retransmission frames is less, so the efficiency of the overall model is increased. Let's take a look at the last point for the difference. The bandwidth required for Go Back N ARQ protocol is too high due to the more retransmission frames. As for SRP protocol, moderate bandwidth requirement is needed. With the completion of difference between SRP protocol and Go Back N ARQ protocol, the User Datagram Protocol, commonly known as UDP protocol, is designed to be unreliable and connectionless in nature, which applies process-to-process communication model for data exchange between devices and is active in the transport layer of the OSI model, and is used to transfer data and information related to internet services over the network channel, where process-to-process communication refers to the use of port numbers in the header format during the transmission of data over the network channel. As for connectionless, it means that the UDP format does not provide established path for the data to transfer. Instead, it uses multiple different paths, which we will look into further in the video. Let's move on to the next heading. Features of using User Datagram Protocol. The User Datagram Protocol provides the network with various efficient and easy to understand network protocol features to apply over the data that is to be transmitted, where the first feature of UDP is related to the working area. That is, the UDP model is a transport layer protocol of the OSI model and is used to deliver best effort delivery options for the data transmission, where the best delivery option refers that the protocol does not provide the sender will receive any acknowledgement from the receiver side for the data transmitted, or it does not provide any guarantee of data transmitted to the receiver side. Now let's move on to the second feature of User Datagram Protocol. The second feature represents the mode of delivery or connection that the UDP establishes for data transmission. The UDP protocol, as we know already, establishes a connectionless path. That means there's no actual virtual path for the data to be transmitted, so that each data from the UDP format uses a random path available in the network channel and reaches its destination. Now let's move on to the next heading, that is UDP header format. The UDP header format comprises of two parts. First, the UDP header part, which is 8 bytes in size, and second, the data to be transmitted. Furthermore, the header part is divided into four different parts: source port, destination port, total length, and checksum, where each of the parts are divided into 16 bits. Let's take a look at the different parts of the header format in a little detail. The first one is source port number. It is a 16-bit value that is used to identify the port that is transmitting the data. Next is destination port number. That is used to identify the port number that will be receiving the data on the receiver end. Next we have total length. As the name suggests, this value is used to specify the total length of the UDP packet, including the UDP header part. And the last is checksum. This is a 16-bit value field and is used as an optional attribute. It is left empty if there is no need, or it is used in case where accuracy of the data is to be measured. Now let's move on to the working of the UDP protocol. To begin with, we have data from the sender side, which is enclosed with the UDP header for communication and data in the UDP header part. The next step is to hand over this data over to the IP section for encapsulation, with the IP header and data with the UDP header and data part. As for the last step, this part is handed over to the frame section, where it is transformed with the frame header and data format. Moving on, now let's transmit the data over the network channel for the receiver end to receive it. Over to the receiver side, the first step is decoding of frame header part and data part into the IP section, which contains IP header and data section. Again, this IP packet is divided into UDP header part and data part, from where the message is retrieved from the data section of the UDP header format and is then received by the receiver end. Now let's move on to the applications of UDP protocol. Let's take a look at some of the features of the UDP protocol that provides applications to various network models. For the first one we have, it provides flow control and error control mechanisms to the network model, such as TFTP. Next, it provides faster transmission of data as there is no pre-established virtual path needed. So it is used for real-time services, live communication, and gaming services. Now let's move on to the last setting for this session, that is UDP versus TCP protocol. We will differentiate between UDP and TCP based on some attributes that are mostly used in a network model. And the first attribute is reliability. For UDP protocol, as we already know now, it is unreliable in nature. That is, it does not provide any guarantee of data transmitted to the destination side is reached or not. As for TCP, it provides reliable and guaranteed data delivery to the receiver side. The next attribute is acknowledgement signal. The UDP protocol does not provide any acknowledgement from the receiver side to the sender side. Whereas in case of TCP protocol, sharing the acknowledgement signal is very important. If the acknowledgement signal is not shared by the receiver side to the sender side, the data exchange will halt. Let's move on to the next attribute, that is connection mode. As we already know now, UDP is a connectionless mode of service. There is no virtual path established for the data transmission to take place. Whereas for TCP protocol, it is a connection-oriented protocol. That is, a virtual path is needed for the data to be transmitted over to the receiver side or the destination node. The next attribute is error check system. In UDP protocol, basic check system is only used for error check. Whereas for TCP protocol, it is an extensive error check service. And along with error flow control mechanism included in the TCP protocol service. Let's take a look at today's agenda. Firstly, we'll understand what exactly the DHCP protocol is. Then the allocation methods in DHCP protocol. Next, we will understand some helpful DHCP settings. And lastly, stepwise we'll understand the operation model for DHCP. Let's understand the DHCP protocol. The Dynamic Host Protocol or DHCP is a protocol that is designed to assign the IP address to a device for it to access the internet. This network model is based on the client-server architecture and removes the process of manually assigning an IP address to the system. Now let's take a look at the allocation methods for the DHCP protocol. The allocation method of DHCP is divided into two types. The first type is the manual allocation, which, as the name suggests, is the assigning of IP address to the system manually by the user. The second method is dynamic allocation, which uses a client-server architecture to assign an IP address to the system. Now let's see some points regarding the allocation method. The first type is the manual allocation. As mentioned, in this allocation type, the user manually assigns the IP address to the system for accessing the internet and can be observed in this instance. This is done by accessing the network configuration setting of the device and also requires other related configurations such as subnet mask, preferred DNS server, and default gateway. Let's now take a look at the dynamic allocation. In this allocation method, the client device receives all the relevant network configurations from the DHCP server, and the system gets configured to access the internet. The provided IP address is given for a certain period, which is also termed as the lease. Now that we somewhat understand what exactly the dynamic allocation in DHCP server is, let's take a look at a small example. Open the Start menu and type command prompt. When the windows open up, type ipconfig/all command. As we see, by this command we can take a look at the network settings for our system. Over here we can see the DHCP is enabled. That means the configuration that has been used on the system refers to the DHCP server. And on the bottom side we can take a look at the different network settings that are given along with the IP address by the DHCP server. That is subnet mask, default gateway, and the DNS server. Now let's continue with the video. Now let's take a look at some of the notable DHCP settings. The first one is known as scope. As the name suggests, a scope refers to a range of addresses that are available to a DHCP server for allocation of the client device. Next we have is lease. This setting of the DHCP server is designed to prevent the hoarding of IP addresses by a single device. This is done by assigning an expiration date to the leased IP address so that the DHCP server has some minimum addresses left for the client device. And lastly, we have address reservation. In this DHCP setting, the client device requests the server to assign the same IP address to the device each time the address allocation takes place. This is done by identifying the MAC address of the client device. Now let's take a look at the operation model for DHCP protocol. The DHCP operations are performed under User Datagram Protocol, in short UDP, which is applied on two ports under UDP, which are ports 67 and 68. The first phase is where the client broadcasts a DHCP server message over the network to connect with the DHCP server. This message basically means that it wants to connect to the internet through the DHCP server. The second phase is when the DHCP server receives the DHCP message. According to the message, the DHCP server reserves an IP address for the client and network configuration information, including subnet mask, default gateway, and preferred DNS server. In the third phase, the client responds to the DHCP server's offer through a DHCP request message, requesting the offered IP address and relevant network configuration for the system. Then in the last phase, the server acknowledges the request broadcast from the client and sends the DHCP packet to the DHCP client, which is comprised of network configuration for the client device.
To begin practicing the commands, we need to access the command prompt application using the cmd command in the start menu. Now, let's begin with the list of commands. The first command is ipconfig. This command displays the system's basic IP address configuration data, which includes network information about IP addresses, subnet masks, and default gateway. Similarly, we also have ipconfig/all command, which displays all the details regarding our device, like LAN settings, physical address of the system, IP addresses, subnet masks, and DHCP information. Let's use the cls command to clear the application window for the next one. The next command is hostname, which is used to access the system's hostname. To verify this, let's use the ipconfig/all command to check the hostname in the information, and for sure, we have the same hostname. Let's perform the cls command again and perform the next command. The ping command is used to check the communication availability of the destination host and the user system. For example, use the ping command with google.com to check the server availability, which gives us the following result. Also, using the results IP address and then the ping command, we can get the same result in case we just don't have the domain name. We perform the cls command again and move on to the next one. The nslookup command is used to troubleshoot network connectivity and find the IP address of a domain like Google and Amazon, as applied just now, to receive the name and address of the domain. Also, using the nslookup command and then applying the server command with an IP address, we can get the domain name belonging to the IP address. And similarly, to check the number of servers with the same domain name, we can do this, and we have 4 name servers for Google. We perform the cls command again and move on to the next one. The tracert command is used to troubleshoot the routing issues of the network by displaying the routing table through which the data is transmitted to a maximum of 30 hops in the network, as you can see. Similarly, you can also try amazon.com and share your views in the comment section below. Now, let's clear the application window and perform the next command, which is the ARP command. This command is applied to display the communication exchange between the IP address and the system's MAC or physical address. Let's move on to the next command, which is the path ping command. This combines the tracert and ping commands and displays detailed information as an output for a maximum of 30 hops in the network. This command takes some time to compile the full hop details so that you can share findings in the comment section. Next, we have the netstat command. It's used to display the network connection summary of the system as shown in the demo. Similarly, if we use the netstat-n command, it will give us much more details about the connection and UDP details. Next, we have the netshare command, which displays the details of where the data resources for our system are shared, and we can check them under the share name, resources, and remark column. Then we have the route command that allows us to access the routing tables and also allows us to make changes to them. Let's try the route print command, and we have the interface list, IPv4 routing table details with all the active routes and the IPv6 routing table. Moving on, let's clear the window and look at the netsh command. The netsh is a popular command which allows us to view and configure the network adapters in the system. Under the netsh command, we have multiple functions for configuring settings. Let's try the show command, and we have the following result. Moving on, we have the task list command that lists all the currently working applications on the system with task or program ID and the memory it uses. Let's perform an example. Access Google Chrome and then perform the task list command. And as expected, we have the Chrome details in the list. And if we close the Chrome window and again use the task list command, we don't have the application active. Similarly, we also have the task kill command, which will terminate the task corresponding to the given program ID in the command window. For example, let's access Chrome and perform the task list command to check the program ID. And then we'll use it with the task kill command and we can see that the application is terminated. To check our result, we can access the task list command again. Next on the list, we have the system info command. It's used to view all the information about the system, from the Windows version to the BIOS and booting configuration. We can access all these details using the system info command. And the last network command for this session is the WMIC command. For getting detailed information on the ports and functions of the system like CPU details, and then similarly, we can check the BIOS settings.
Let's start off with question 1. What is the OSI model? Explain the different layers of the OSI model. OSI largely is a theoretical model utilized to understand networking and how data packets are created and how they are being processed by a computer. This is normally used by the TCP/IP, the Transmission Control Protocol over Internet Protocol software suite. So OSI is known as the Open Systems Interconnection model. It is a reference model that describes how applications are going to interact via the computer network. There are 7 different layers that we need to understand. They are as follows. So in this diagram, there are these 7 different layers. We start up from the bottom. First is the physical layer, the data link layer, network layer, transport layer, session layer, presentation, and application. When such a question is asked in an interview, it is not only that we identify these 7 layers, explaining what the OSI model is in the first place, we then try to identify these 7 layers and we give a brief description about each and every layer. If there are any additional questions, they will come after this basic question. So let's start off with the physical layer. This is the lowest layer of the OSI model. Now this is where any and every physicality of your computer comes into the picture. So it could be a network interface card, it could be an RJ45 or a Cat5 cable, anything that allows data to be transmitted physically from your machine to another machine. Next comes the data link layer. So on the data link layer, as far as networking is concerned, we just need to understand that data packet is encoded, decoded into bits at this layer. This is also the layer that deals with MAC addressing. So the physical address of every network interface card, which is the MAC address, which is utilized to route data packets over the network. This is where the MAC address resides, on the data link layer. The next layer is the network layer. Here datagrams are transferred from one to another. The function of this layer are routing and logical addressing. The moment we talk about routing and logical addressing, IP addresses come into the picture. IP version 4, IP version 6. So network layer will deal with IP addressing and the routing of those packets. Then comes the transport layer. This is the layer responsible for end-to-end connections. That automatically signifies that this is where TCP and UDP will be working. TCP stands for Transmission Control Protocol, UDP for User Datagram Protocol. TCP is a connection-oriented protocol, whereas UDP is a connection-less protocol. These two protocols are utilized to establish connectivity between two machines. TCP is a more reliable method of connectivity because there are a lot of packets that are sent across to verify that the data has been sent, data has been received, and so on and so forth. Whereas UDP is a connection-less protocol where data is just dumped without verifying whether the receiver actually receives that data or not. So in a nutshell, on the transport layer, TCP and UDP make their appearance, and this is where that functionality lies. Then comes the session layer. This controls signals between the computer. It establishes, maintains, and terminates connections between processes. So in the transport layer, we talked about TCP and UDP. UDP being a connectionless protocol where data is just transmitted without verifying whether the receiver received that data or not. Whereas TCP, we studied, is more of a reliable protocol. Thus, there are different packets, signals that will be sent across to verify that data has been transmitted, it has been received properly, and then the next segment of that data is being sent. So those control signals are established using the session layer. So the three-way handshake of TCP, the acknowledgement packets, and those kind of packets will be taken care of on the session layer of the OSI model. Then comes the presentation layer. The presentation layer is responsible to translate data into the application layer format. So the formatting, right? MIME or encoding that is being utilized, the UTF-8 character set that we utilize for presentation, encryption mechanisms, all of these work on the presentation layer. And finally comes the application layer, where the application itself uses a particular protocol so that the other machine on the receiving end, the application on that machine will be able to understand what the communication was about, right? So in a nutshell, if I start from up top, the application layer will deal with any of the data that the application is generating. So maybe a user input, you're logging in, you're typing the username, password, all that data will be constructed, let's say, into an HTTP or an HTTPS format. That's where your application layer comes into the picture. Then the formatting of which into UTF-8 and the encryption of which would be done at the presentation layer. Then this transport layer and the session layer would kick in to establish a TCP session, do the three-way handshake, establish that connectivity. IP addressing would be done on the network layer, MAC addressing would be done on the data link layer, and when everything is ready on the physical layer, the packet will be sent out. At the receiving end, the packet will be received on the physical layer, and then all these layers will be reversed, and finally at the application layer, the data would be presented to the application, who would then execute it and showcase it on the screen of the recipient. So this is the way you want to explain this question. You want to be very concise, precise about what you're explaining. You don't want to go into too hypothetical scenarios. You don't want to dilly-dally with the layers. You just want to give the basic functionality, want to demonstrate that you understand what the OSI layer is, how the computer functions, and you want to move on from there. If the interviewer has any further follow-up questions, they will ask those specific questions. So that's question 1. Moving on to the question 2. Question 2 is define unicasting, multicasting, and broadcasting. Now this is a question which can be very lengthy, but again, most of your interview questions are designed that way. It's basically to understand how much conceptually you are aware about these technologies. So you have to be very concise. Don't go rattling about technology too much, but in a concise manner, just try to explain what these things is. So when data is being transmitted over a network, it can be transmitted either in one of these particular manners. It can either be a unicast, multicast, or a broadcast. So what is unicast? Unicast is when a message is sent from a single user to a single receiver. So one to one, right? So one machine talking to another machine and nobody else. So also known as point-to-point communications. One point to another point. If you have to send information to multiple receivers, then you will have to send it using multicast, right? So this is where your multicast networking comes into the picture. So in our case, let's assume it's a network where there's a class C network, approximately 255 odd machines. And within these, there are two machines that want to talk to each other. If they want to talk between each other, it would be a point-to-point communication where they will utilize unicast, where only these two machines will have visibility of that conversation and the other machines will not even realize that this conversation is taking place. If one machine wants to talk to multiple machines, then the multicast comes into the picture. As the name suggests, in this mode of communication, data is sent from one or more sources to multiple destinations. Multicast uses the Internet Group Management Protocol, also known as the IGMP protocol, to identify groups. So under this IGMP protocol, various groups are created where machines are subscribed to those particular groups. And whenever a message needs to be sent through those groups, it will be identified by the IGMP protocol and then that particular message will be sent to those multiple machines that are members of those particular groups. And then comes the broadcast. The third method is known as the broadcast. As it says, it is going to broadcast to all. So this is one to all, that is communication between a single user, and it is going to be sent to all the machines in that particular network, right? So the three ways: unicast is one to one, multicast is one to many, and broadcast is one to all. Then question number 3. What is DNS? DNS stands for Domain Name System. It is like the internet's phone book that is responsible for mapping the domain name into its corresponding IP address. And let me give you an example over here. Whenever we go and open up, let's say, a browser, a Google Chrome browser, we type in www.google.com and then we press enter, and magically Google comes in front of us, the website rather. Now, how does the computer know who Google is? Because as far as we are concerned, humans understand Google and words like that. Computers don't. Computers deal with binary, zeros and ones, right? And as far as internet is concerned, they will only deal with IP addresses and MAC addresses. So how does a computer know how to find google.com and where is it located? So the moment we type in the browser window, in the address bar, google.com and press enter, a DNS query is generated automatically by the browser, where a packet is sent to our DNS servers asking what the IP address is. So in short, DNS resolves domain names to their corresponding IP addresses. There is a DNS server which will have this index, a database of all the domains associated with their IP addresses. If one particular DNS server does not have that information that you're looking for, it may query another DNS server who may have that particular response. So the first thing is, when you type in domain name, it gets resolved with the DNS. It identifies the IP address corresponding to that particular domain name, and thus allows the computer to route that packet to the particular server where that domain name resides. So in this scenario, if you look at the screen, on the local PC, you have typed in cybersecurity.com. There is a DNS resolution, that a query that goes to the DNS server. What is the IP of cybersecurity.com? The DNS server looks it up in its particular database. If it has the corresponding IP address, it will then respond back. The IP address is 172.17.252.1, after which the packet is sent off to cybersecurity.com. Moving on to question number 4. What is a firewall? Now, this is a very good question, and normally a very basic answer that I've ever heard is that a firewall is a hardware and a software firewall. But that's the functionality of a firewall. That is how you can install a firewall. But there are different types of firewalls, and there is a specific functionality that a firewall is created for, right? So a firewall is either a hardware or software, but its responsibility is for blocking either incoming or outgoing traffic from the internet to your computer. They secure a network. So essentially, the firewall will allow a connection to happen or disallow a connection to happen. It won't go beyond that. That's the basic functionality of a firewall. Okay. So based on the configurations that you have done, based on the rules that you have created on the firewall, it will then, based on those rules, identify whether some traffic is allowed in that network or some traffic is to be blocked from entering that network. So as the screen shows, the firewall rules will analyze whether the traffic is good. If yes, it will allow. If the traffic is bad, it will block the traffic and not allow that connection from happening in the first place. Now, there are a few common types of firewalls that also need to be included in the answer to this question. And the first one is a packet filtering firewall. These are the most common types that you will come across, which analyze packets and lets them pass through only if they match an established security rule set. Now here people do get confused when we say that we analyze packets. People think that these firewalls will analyze the contents of that packet, which is not correct. When a definition for a packet filtering firewall says that these firewalls analyze packets, it means that they are only analyzing the source and destination IP addresses, port numbers, and the protocols that are mentioned in those packets. These firewalls do not have the capability of deep packet inspection, or DPI as it is known. If that capability comes into the picture, you're basically looking at an intrusion detection system or an intrusion prevention system in today's world called as a next-gen firewall. Okay, so a packet filtering firewall essentially will only analyze data packets for its source and destination IP addresses, port numbers, and the protocol that is being utilized. It will then map that information to the rules that are there on the firewall, and based on those rules, it will either allow that connection to happen or disallow that connection from happening. The second type is a proxy firewall. These firewalls filter network traffic at the application level. So when you say application level, they work at the layer 7 of the OSI model. Packet filtering firewalls, since we have mentioned that they worked on IP addressing and port numbers, will work on the network layer of the OSI model. Also on the transport layer, because they also look at protocols. Proxy firewalls will work at layer 7, which is the application layer of the OSI model, and will deal with application level protocols such as HTTP, HTTPS, FTP, SMTP, and so on and so forth. And the third one is a stateful multi-layer inspection firewall. These filter packets at the network, transport, and application layers. So they basically do the job of the first and the second type of firewalls. The packets are compared to known trusted packets. But now the first question is, if there is a stateful multi-layer inspection firewall, why do we have type 1 and type 2 firewalls like packet filtering and proxy firewalls? That is because that is how the firewalls have evolved. We started off with the packet filtering, then we added functionality to it, and so on and so forth. So if a question comes, what is a firewall? You start off with the option saying it is a hardware or software. This is the responsibility, the functionality of a firewall is to allow good traffic and disallow bad traffic based on the rules that have been configured on the firewall. And then you've got basically 3 types of firewalls: packet filtering, proxy, and stateful multi-layer. And just include a brief description of each of these firewalls.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Then moving on to question number 5. What is a VPN? VPN is also called a virtual private network. It is a connection between a VPN server and a VPN client. So it basically creates an encrypted tunnel between the client and the VPN server, which is then utilized to secure the connections that you're making with the internet. So as you can see in the diagram, the user has a VPN client installed on their machine. The VPN client then creates an encrypted tunnel to the VPN server. And through this tunnel, encrypted data is transmitted, which can then be processed by the VPN server, sent to the internet. Information can be received back by the VPN server. The VPN server will encrypt that data back and send it back to the user. So if there is a man-in-the-middle attack that is happening, or a hacker trying to eavesdrop on the communication mechanism, they will not be able to do so because of the encrypted tunnel. It is very difficult to decrypt this or hack through this encrypted tunnel. It is possible, but it is very difficult to achieve that. Moving on to question number 6. What are the advantages of distributed processing? Now, before we go into advantages of distributed processing, we first have to understand what is distributed processing. So it is a term which describes various computer systems that use more than one processor to run an application. Here, multiple computers across different locations share the same processor. The advantages of distributing processors are as follows. But before we go into the advantages, distributed computing is basically where multiple machines will pool their resources together to run a singular application. So an application that has multiple resources and can scale up and scale down as and when required. The advantages are that it can be very useful in data recovery. For example, RAID, where you're striping data on various hard disks. It is reliable, it is cheaper, lower cost can be achieved, and it is easy to expand because of the scalability factor that we just talked about. If there is loss of data in one computer, it can then be recovered by another interconnected computer. And one of the examples would be blockchain in today's world, right? What is blockchain? That this data is created live and stored on a connection of computers. So if one of the computers goes offline, the other computers in that network will still have that data, and the blockchain will still function without any issues. The second point, a glitch in one machine does not affect the processing, as there will be multiple other machines like we discussed in the blockchain. Several cost-effective mini computers are used instead of costlier mainframe machines. So instead of having a server bank, I can have multiple machines interconnected together, and they can function in that particular blockchain or for that particular distributed processing mechanism. Depending on the amount of data processing, more computers can be attached to the network. Thus, you can increase the number of computers that can be a part of that blockchain, or you can reduce them as and when necessary. Moving on to question number 7. What is TCP/IP? TCP/IP, or Transmission Control Protocol over Internet Protocol, is a set of communication protocols that are used to interconnect networking devices on the internet. This protocol defines how data should be transmitted over the internet by providing end-to-end communications. So essentially, if you want networking to be established on your machine, you will need TCP/IP. Without TCP/IP, there will be no work groups, there will be no domains. Basically, your interconnectivity will go for a toss. TCP/IP is a software that once installed on your machine will then interact with the hardware, which is your network interface cards, and then your switches, wires, cables, and all those, through protocols that have been already pre-configured in it. So within the TCP/IP suite of softwares, you will have all the protocols, all the functionality of the OSI layer, and each and every protocol that works on each and every layer will be predefined and pre-configured to work in a particular manner. The Internet Protocol is all about routing each individual packet to make sure it reaches its destination. So with the TCP, you're talking about the protocols that will allow you to format the data and generate it so that you can communicate it over the network. The IP will then deal with the routing of those packets so that the packet can be routed to the correct computer and be received by the recipient. So the TCP/IP model is the compressed version of the OSI model. The 7 layers will get converted into 4 layers: the network access layer, internet layer, transport layer, and application layer. Going on to question 8. What do you mean by ipconfig and ifconfig? Both of these are commands, the first one on a Windows machine, the second one on a Linux machine. So ipconfig is known as the Internet Protocol Configuration. This is a command that is used on the command line interface of Microsoft Windows to view all the adapters and the configuration of each and every adapters for their network interfaces. So as you can see on the right hand side in the command prompt screen, if once you type in the ipconfig command on the C prompt and press enter, it will give you a list of all the adapters that are there. So you can see wireless LAN adapter, local area connection, the media is disconnected, it doesn't exist. At the bottom you will see the Wi-Fi connection, wireless LAN adapter, and it can give you the IP version 6 IP address, IP version 4 address, the subnet mask, and the default gateway. So this is the configuration that allows the machine to know on what network it is on, what is the default gateway for communicating to the internet, what is the subnet mask, so how many computers may exist in that particular network, and what is the IP address of that specific computer so that it can communicate across the network as well. ifconfig is the same thing on a Linux, Mac, or Unix operating system. So the command will also give you the list of interfaces and the configuration of each and every interface. It is used to configure, control the TCP/IP network interface parameters from the command line interface. It allows you to see the IP address of these network interfaces. So here you can see the WLP19S, the IP address being 192.168.43.215, subnet mask being 255.255.255.0, with the broadcast being 192.168.43.255. Question 9. What is the difference between a domain and a work group? This can be a very interesting question and can be a very lengthy question at the same time. A work group is nothing but a decentralized network where you have interconnected multiple machines together and each machine acts in its own individual capacity. Thinks of itself as a server, right? So a decentralized network, every user manages the resources individually on their PC. So local users on their own PCs managing the network shares, what can be shared from that particular machine, what data should be shared, should not be shared, to whom it can be shared with, and so on and so forth. It is good if you've got a small network, a few machines altogether, and you want them to interact with minimal management effort, right? So each computer, each user will decide what they want to allow other users to see on that particular network. And all of them would be connected over a LAN, a local area network, either a wireless or a wired one. So if you look at your home Wi-Fi right now, that is one of the best examples of having a work group. The domain, on the other hand, is a centralized network model. So in a corporate environment, whenever you go there and you got a domain-based username and password, which when entered onto a particular machine gives you access to the entire network or whatever applications and whatever resources have been allocated to you, That is where the domain comes in. So it also uses a single sign-on mechanism for all the resources that are to be made available to you. Whereas in a work group, you're a local user only meant for that particular computer, right? So coming back to the domain, it is an administrator who's going to manage the entire domain and all of the resources connected to the domain. The resources could be switches, routers, servers, data stores, applications, web servers, mail exchange servers, and so on and so forth. So all of these are administered by an administrator through the domain. It is the most reliable and the optimum solution for a large network where multiple users are going to interconnect and share that data amongst each other, right? The computer can be connected to any network. That means you can be on the internet, and through the internet using a VPN, you can connect to your corporate network, authenticate in, and get access to whatever resources you are allowed to access. Whereas in a work group, you have to be a part of that network to access that particular network. If you change your location, you go and connect to another Wi-Fi, you will lose access to your previous Wi-Fi. Then the last question for the networking section, what is data encapsulation in networking? Data encapsulation refers to the process of adding headers and trailers to the data. The data link layer binds each packet into a frame that contains the hardware address of the source and the destination computer. So in this example, when you're talking about data encapsulation, we have talked about how data that has been created by the application layer would have a header and a trailer that will give the various informations of where that data needs to be sent. So the hardware address, which is the MAC address, comes into the picture and gets added to the header, and the IP addresses, port numbers, and all of those things would then be added to this trailers as well, so that the data can be then routed to the intended recipient of that particular communication.
And that's a wrap on our networking crash course. We hope you found this video informative and that it helped demystify the world of networking for you. Remember, networking is a vital skill in today's interconnected world, and with the foundation you have built here, you are on your way to networking success. If you enjoyed this crash course and want to see more content like this, don't forget to hit that subscribe button and ring the notification bell so you never miss any update from our channel. Feel free to leave your questions and comments down below. We are here to help you on your learning journey, so don't hesitate to reach out. Thanks for joining us today, and remember, the world of networking is vast and ever evolving. So keep exploring, keep learning, and keep networking. Until next time, stay safe and keep learning.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.